Welcome back, my favorite Python programmers, to a brand new video, and in this one we're going to be working on 5 Python exercises to test out your knowledge. My name is Michael, founder of the teaching institute that is 2M Python Dev, and my goal is to make you the best Python programmer in the most fun way possible. This is going to be part 2. You can go and watch part 1, but you don't have to. You can watch this one, but keep in mind this one has more advanced topics. As always, I'm going to be leaving timestamps in the description or the pinned comment. Also, there are resources in the description or the pinned comment that you have to use for some exercises. And if you're new to the channel, every exercise starts off with a program guide. So whenever you see this slide somewhere around, that means that you have to go through this guide on your own before you start the program with me, just to test things out, make sure that you try to do your best, and then you can follow along with me as always. Also, in every video there is something called a challenge. So whenever you see this red or this slide with the red bars around it, it means that you have to pause the video and go through the steps that I've told you so that you can test out your knowledge and try to do your best. It's not just for you to make sure that you always do it correctly, but when you test yourself out, you try to do your best. Even if you fail and then you see the solution to it, it's more ingrained in your mind and you learn better and faster. If you have any questions, you can always leave them in the comments below. I reply within 12 to 24 hours. And that's basically it. So let's go ahead and get started. In this one, we're going to be creating a functions inventory system as a Python exercise, and we'll be covering the following topics. So if at any point you feel that you're enjoying the contents of this video, please make sure to smash that like button because I need to beat the YouTube algorithm, and let's go ahead and get started. Okay, so this is going to be the inventory system program guide. Again, let me just tell you, if you're new to the channel, basically what I will do is I'm going to guide you through the process. You can go and do it on your own and then come back to my guide and watch how I did everything through the walkthrough. Or if you want, you can do every single point that you can, watch the video, then if you're stuck somewhere, go to where I am, etc, etc. Anyways, first thing is you'll need to create a dictionary in which the keys are item name, or the item name, and the values are a dictionary with the quantity and the minimum stock as a key. So basically, you are going to be creating a dictionary that contains a dictionary inside of it. And you'll have the keys as the item name, and then the values of these keys are going to be quantity and the minimum stock as the keys. So we're going to have one dictionary and then another dictionary inside. Next, you'll need to create an add item function that takes in 3 parameters: the name, quantity, and the minimum stock for an item. Then you'll check if the item is already in the inventory, then the quantity should be increased and the new minimum, and you'll need to set up a new minimum stock. Otherwise, the new item is added. So if the item is already in the inventory, you increase the quantity and you set a new minimum stock. Otherwise, a new item is simply added. Next, you'll need to create a search item function that finds a specific item sent to it, finds a specific items. This is a mistake. It finds a specific item sent to it as a string and returns its info. Otherwise, returns no found message. So search item takes in 1 parameter, which is the name of an item. And then based on that, you return the information, which is the quantity and the minimum stock. And finally, you'll need to create a list inventory function that prints out all the items with its details. Use the .items method to go through the dictionary, and this is true for any of these parts. So if you want to go and tackle this program on your own, pause the video right now and go ahead and try to do it. Okay, so as you can see in here, we create a dictionary variable called inventory. This dictionary has keys that are the names of our items, such as apple, bananas, and oranges, and each key is associated with another dictionary as its value. So as you can see, this is a second dictionary, and these inner dictionaries contain 2 keys. the quantity and the minimum stock. The quantity holds the number of items in a stock. So for example, inside of our inventory, we have 50 apples, we have 20 oranges as the quantity, and the minimum stock indicates the minimum number of items that should be in stock or in our inventory. So for example, apples should have, or we should have at least 10 apples as our minimum stocks. So the inventory dictionary keeps track of how many of each item we have and what is the minimum acceptable stock level for each of those items. Okay, so first thing I did is I increased the font of my code so that you can clearly see it. Sorry if this one was not as clear. Next, what I did is I defined a function called add item. The function takes in 3 parameters: the name, or the name of the item, the quantity, or the quantity of the item to add, and the minimum stock, which is again the minimum stock for each of the items. We've already kind of explained these. Now inside the function, we first check if the item name already exists in the inventory, and we can do this using the in. If you're not sure how this works, I'm going to link the video where I explain dictionaries fully from A to Z, so you can go ahead and check that out. Now, if the name is in the inventory, which means the name would be, for example, apples. If apples is in the inventory, then what we do is we increment the quantity of that item name by the quantity that's provided to us. And the way that we're able to access the quantity of a specific name is using these 2 square brackets, one after the other. So first we access the actual item using its name inside of the inventory dictionary. Then we access the quantity of the dictionary that's inside of said item, and then we increment it. And we do the same for the minimum stock, and then we just have this simple printout just so we know that everything worked fine, printing out the quantity, the name of the item, and finally how much total quantity there is. Now, if the name is not in the inventory, what we do is we are going to create a new inventory item. And the way we do this is by simply saying that this inventory, or inside of this inventory dictionary, we're going to create a new key with the name that is being sent to us, and that key will have a value that is the following dictionary that has quantity and the minimum stock. And again, we have this simple printout just to indicate that a new item was added, unlike what we had in here where the quantity was incremented. And again, if you're not familiar with how we operate on dictionaries, I highly recommend that you go watch the video. These are very simple stuff. When we say name in inventory, we're basically going through all the keys in an inventory and we're checking if name is in any of these. If you're familiar with how lists work and tuples, this is very similar. And again, we also have the following. This might be confusing for some of you because you've never worked with a dictionary that has a dictionary inside of it. So you might be familiar with this part, but you might be unfamiliar with this one. Just apply the same logic. We were able to access, for example, let's say in this example with the add item, where we had apples. First, let's right click and run. Also in here, I added the apples, added the cherries, and finally I printed out the inventory as well. So let's see, 20 apples added. So if you remember, we had 50 apples, now we have 70 apples. Cherries added to the inventory with a quantity of 40. So because we didn't have cherries previously in our inventory, which means that this condition was not true, which means that we went into the else statement, a new item inside of the inventory was added. And if I move this along in here, the big font doesn't help me. There we go, cherries with a quantity of 40 and a minimum stock of 60. So there we go, that is perfect. Now, even though, remember we said the minimum stock should be 60 and we have a quantity of 40, doesn't really make sense, but for now, we'll just think of it as an inconvenience, and later on we'll create functions that handle such problems. And by the way, the plus equal signs, I've already explained this many times, it means that we are incrementing, unlike what we're doing right here, where we are setting the minimum stock to the minimum stock that's been sent to us. So let's go ahead and continue on. One more thing in here, I realized that I'm adding apples and setting the minimum stock to 10, which was already 10. Let's try something else. Let's try just 7 and see how that works. So now apples, you can see that they have a minimum stock of 10. Okay, so in here we define the function search item. This function accepts one parameter, that is the name, which is a string, and we did this by adding a column, and then next to it we added str, which means string. This function also returns nothing, and we indicated that using the following syntax, where we have a dash and then a bigger sign, or whatever this one is called, I always forget. Basically, this arrow, you can draw it with the control and dot, depends on your keyboard, and then none, which means nothing. And inside the function, we added this following annotation. Now, why did we do this? So normally, if for example, you're using the print and I hover over the print, you can see that it fetches information, and you can see right here that we have values as objects, separators as strings, the and as a string. So all of these are indicators, and you'll see that the print also returns none. Now, in our add item, by the way, I commented out, if I hover over the add item, you can see that it doesn't really get us anything. It just says names, any, quantity, any, and it does return none, but this is because we already ran it and PyCharm understood that it returns nothing, or also because we don't have any return statement in here. But now look at the search. If I hover over the search, you can see that it actually provides me with documentation and the actual documentation that I wrote inside. So notice, search an item in the inventory, search an item in the inventory. The name is a string, none or nothing is returned, and I also have this param's name. By the way, it was added automatically when I added these three double quotation marks, and I hit tab or enter, I believe, and the params and the name, the param name and the return were added automatically. So from here, let's continue. These annotations are very important because later on you'll have to do them in a challenge. So keep that in mind. I kind of gave away the challenge, but anyway, inside the function, we check if the item name already exists in the inventory, again, using the in, going through the keys, and if it does, we retrieve the item's detail from the inventory, which are stored in a dictionary with the keys, quantity, right here, and the minimum stock. So we then print these items out in a very nice looking, this item's information out in a very nice looking printout statement. So basically all that we do is we access the inventory through the name that was provided to us, if the name was in the inventory. If it's not, we simply say that the item is not found. And next what I did is I simply commented out these three lines where we add items to the inventory. This is just because I want to make sure that I focus on this. And two main things that I did not talk about when I created the add items, and I should highlight. First of all, if you use in here quantity with a uppercase Q, this is not gonna work. This is actually going to cause an error. Let me show you. If I uncomment this and I right click and I run, you can see that I get a key error quantity. Because we're working with strings, that means that uppercase letters make all the difference. So a uppercase Q is different than a lowercase q, or a quantity without an N is also not going to work. So make sure that you use the proper names. And I recommend that you actually copy them. Whenever you're working with string references, you have to actually copy them, or it's safer to just copy them. The same thing goes here. If I use orange with a capital O, even though we do have oranges in here, right click and run, you can see that oranges not found in the inventory. But if I do the following, right click and run, you can see that the items are oranges, quantity is 20, and the minimum stock for oranges should be 5. Okay, so as you can see in here, we again created or defined a function that is called the list inventory that does not take any parameters this time. Inside the function, we use a for loop to go through each item in the inventory. So as you can see right here. But if you're not familiar with the dot items, again, I recommend that you go and watch the video on dictionaries that I've linked somewhere around. It returns two things in here. So the inventory dot items returns a list of key and value pairs. You can see the item in here is going to be the keys or the name of the inventory item, and the details are going to be the value, which in this case are the following dictionaries that contain the quantity and the minimum stock. So when we use the dot items, this might be a crazy phenomenon for you, but this is very normal. The items returns all the keys and value pairs, but because the details or the values of our dictionary are actually dictionaries themselves, that means that we have to apply these keys right here on them to access their information. So for each item, we print out a formatted string that includes the name of the item right here. Yes, right here, the name of the item. Then we include the quantity and the minimum stock, which are inside of the details dictionary. And basically this function provides a simple way to view the entire inventory, showing each item's name and how many there is, or what's the quantity in the stock and what's the minimum stock as well. So when I right click and I run, you can see that right here I have the apples, bananas, oranges, and let's go ahead and uncomment the following. So now we should see that the quantity of apples is 70. You can see right here apples were added, cherries were added. So now when I look through the inventory, I can see that I have 70 with 7 as a minimum stock, and we have cherries at the end with a quantity of 40 and a minimum stock of 60, which is really, really cool. Okay, my fellow Python programmers, congratulations on going through the program walkthrough. It was kind of challenging, especially if you're unfamiliar with dictionaries or if you are a complete beginner. It's very natural to feel a little bit overwhelmed, especially when you have a dictionary inside of another dictionary. This is basically like Inception. You have a dream inside of a dream, so you have to kind of figure it out. I'm no Leonardo DiCaprio, but anyways, this is kind of getting bad. In any case, if you were able to do this entire program, congratulations. If you did not even try, now's your chance because it's time for a challenge. Let's go ahead and look at the challenge together. Okay, so it's time to remove and analyze your inventory. First of all, you need to create a remove item function that takes in two parameters, the name and the quantity, and deduce the item's quantity by the amount sent to it. First, you need to check if the quantity argument is not provided, then the default is going to be 1. So this is the use of default parameters. If someone doesn't provide how much quantity they want to remove, then only 1 should be removed. Next, the quantity should never go below 0, of course, because you can never have minus 10 apples. And finally, if the item's quantity gets less than the minimum, or in the minimum stock, a warning message should be printed out. Next, you'll need to annotate all the functions properly, just like I did with the search item function. Create a find most stocked item function that returns a tuple containing the name of the most stocked item and its quantity. And you also need to annotate this. So this is a very, very nice challenge where you have to think of, how do I annotate? How do I tell someone that this returns a tuple containing the name and the quantity? Very nice. Create a find the least stocked item function that returns a tuple containing the name of the least stocked item and its quantity. And finally, you'll need to create a calculate total inventory value function. As you can see, I'm very good at naming these functions, very short, very precise. A function that returns the total values of an inventory, assuming each item has the same value. So this function should basically take in the price of an item, and then you get the total amount of everything and multiply it by that value, and you get, well, the total value of everything in your inventory. So pause the video right now and go do the challenge. Okay, so as you can see, first of all, I minimized the inventory and the previous functions that we've created so that we have more space to create new functions. So first of all, in here, as always, we've defined a new function called the remove item that takes in two parameters, the name and the quantity. Now the name, of course, it's going to be the name of the item that we want to remove, and the quantity is the amount of units or number of items that we want removed. Now, as I told you, if no quantity is provided, like right here on the apples, then the default value should be 1. And the way that we do this is we say that its quantity equal to 1. So inside of the function, what we do is, first of all, we check if the name is already in the inventory, meaning that we check if the item exists in our inventory, but we also check if we actually have enough quantity to remove, because remember, I told you quantity can never go below 0. So we need to check in here if the quantity is greater than, or using the name, after we've checked that the name is actually in the inventory, we check if the inventory at that name or at that item at the quantity that it has. So again, in here we're accessing the quantity inside. Let me open up the inventory again. So again, we access the quantity of a certain item and we check if it's greater than the quantity that's being sent to us. And if it is, if both of these conditions are true, because when we're working with an AND, we need both sides to be true, otherwise it will not work. If this one is false, but this one is true, it will not work. But if this one is true and this one is false, it also will not work. If both of them are true, that means that we have the item in our inventory and the quantity is enough. Then we're going to go inside of the if statement where we reduce the quantity of said item by the quantity sent to us using the minus equals. Just like we've used the plus equals, we can use the minus equals to decrement. And then we print out that this item was removed and the remaining quantity that we have. But we also check if this removal brings the item stock below its minimum required level, that is the minimum stock, and then we print out a warning sign right here. So the way we do this is we access the quantity of that item and then we access the minimum stock of that item, and if the minimum stock is greater than the quantity, then we print out a warning message. And finally, if the name is not in the inventory or the quantity is not enough, we have the else statement right here that prints out error, insufficient, etc., etc., or the item is not found. So in here, after I've added some of my items, I'm going to remove 5 bananas. As you can see right here, I have 30, so this should be good. Then I remove apple, but notice I did not specify how much I want removed. So this should be, this will be a great way to test out if our default value or default parameter works. And finally, I try to remove pineapples that do not exist. And one more thing I want to do is I want to remove 500 apples just to see if our little if statement right here works. So right click and run, and as you can see, 20 apples were added, cherries are added, 5 bananas were removed, and you can see that we have insufficient apples, or insufficient pineapples, or the inventory, or they do not exist. So okay, I just noticed something, and I was thinking, why do I have an error or an insufficient amount of apples? That's because it's not apples, or I mean, it's not apple, it's apples. So there we go. As you can see, this can be a huge problem. Now when I right click and I run, you can see that 1 apple was removed and 5 bananas were removed. And we can see that bananas were 30. And when we print out the list right here with the list inventory, you can see that now bananas are 25 and apples are 69, funnily enough. One more thing, when I tried to remove 500 apples, we got an error. When I tried to remove pineapples, we also got an error. So everything seems to be working fine. Okay, so now I am annotating my functions. As you can see right here, the name is a string, the quantity is an integer, and the minimum stock is an integer. They cannot be floats. Of course, you cannot have 2.5. I mean, you can have 2.5 apples, but does that even make sense? And of course, it's a none. As you can see in here, I added these 3 double quotation marks, add or update the item. Once I hit enter, or I wrote the 3 double quotation marks and hit enter, you can see that it added the params right here and the return, which is nothing. I'm going to do the same for the list inventory. As you can see, the search item is already annotated, so you can take remarks from that. Okay, so I wanted to stop here just to tell you about how this one works, which might have been confusing. So the name is a string, very easy. It returns none, very easy. The only issue was that right here, how do we say that the quantity is an integer and it has a default value? Some people try to do it like this. So add the 2 dots and integer afterwards, but no, it's not how it works. You first have to indicate that the quantity is an integer and then say that its default value is 1 if nothing is provided. Okay, so this is the new function that is the find the most stocked item. As you can see, I'm brilliant at naming my functions. In here, I told that I no longer return none, just like we had with all of our previous functions that we've created. This time we return a tuple, and inside of the tuple we have a string and an integer. In here, as you can see, I said that we find and return the item with the highest quantity, and the return is just in here, nothing. I mean, this was the default that was given to me. Anyway, in here, what we do is kind of maybe spooky to some of you, but this should be pretty familiar. Again, I haven't created a full length video about list comprehensions, but I did create a short video and I'm going to link it somewhere at the top. So the function, again, returns a tuple that contains a string and an integer, where the string is the name of the item and the integer is the highest stock. Now inside, what we do is we create this quantities item, which is a list. And how did I know it's a list? Well, because we're using list comprehension. We have these 2 square brackets on either side. Now let me break this code down. So first of all, in here, this is a tuple. The reason why I knew it's a tuple, because it has these non-square brackets. I don't know what they're called. That's just normal brackets, round brackets around, and we have 2 items, the details with quantity inside and the item next to it. And right here I have 4 items, details in inventory items. So this is very similar to what we did right here in the search. No, not in the search. Exactly what we did in the list. In the list, where we have, this is the same format right here. So if you can understand this, it's exactly the same as this one, but now we have it on a single line. So we say that we want to create a tuple that has the quantity inside of the details dictionary. The second item of the tuple is going to be the item, and then this is, or we create this list of tuples for item, details in the inventory dot items. Again, I will link it somewhere. If this is the first time that you see list comprehension, you might be shocked. You might be like, oh my god, why am I learning such advanced and futuristic methods? It's very, very simple. The reason why I wanted to make it into a list is because I wanted to find the max quantity. So after creating a list of tuples that has the quantities and the names of the items, I then find the highest quantity with the most stacked items, and I return this tuple right here. So let's go ahead and call this function. So right here after the list inventory, I'm going to print out just a couple of, or you know what? Let's make the find least stocked item, and then we will call both functions. Okay, so as you can see, I simply copied the find most stocked items and made some modifications. First of all, I called it the find least stocked item. In here, in the description of the function, I said that the least quantity, and then I called this one, instead of the highest, the least, or maybe it should have been the lowest. So the lowest quantity, boom, boom, lowest, and then the least instead of the most stocked item. This is just simple variable name changes, so they don't really affect anything. But what does affect things is instead of the max, I used the min. So right here, I'm going to print out about 50 dashes. So multiplied by 50, this creates 50 dashes, and then I'm going to print out the find least stocked, or find the most stocked, duplicate this line using Ctrl D, and find the most, find the least stocked. So I use this print to separate things, and then I print out the find most and find least. Right click and run, and as you can see, apples is the most stocked and oranges is the least stocked. And if we go back to the inventory, you can see that 50, 30, and 20, and even when we add cherries, you can see right here that 40 is still higher than what we have with oranges, which is 20, so everything works. Now you might be thinking, why did we use a print in here? Well, because these two functions don't print anything themselves. They simply return the least stocked or most stocked and highest quantity. So we have to actually print them out, because if we don't, I'm going to show you, for example, right here, if I simply call it, I don't get anything. Nothing is printed out. So we actually have to print out the values that are being returned to us. So I hope that is clear. Okay, so let's go back right here. First of all, we created or defined the calculate total inventory value that takes in the item value as a float. This time, yes, it is a float, not an integer. Why? Because the price of something can indeed be 5.2, 7.3, etc, etc. So it's appropriate to use a float in here. Next, we said that this also returns a float. So this is the first time that you see that we, instead of returning like a tuple, which is kind of complicated, I know, but in here we simply return a float. We have the description of the function, and in here we sum up all the quantities of the items in the inventory. Now again, in here we're using a spooky new method that is the dot values. And by the way, what's the difference between a function and a method? Well, a function is what we created right here, where we can simply call it out of nowhere without anything, but a method is when we actually apply it to an object. So for example, inventory dot values, and by the way, if you don't know what objects are, I'm going to again link the object-oriented programming guide or video somewhere around here. So the inventory.values, the .values function returns all the values. So you can also have the .keys, which returns all the keys. The .values returns all the values, and the .items returns the keys and the values at the same time. So right here, the values are returned. What does that mean? That means that we get these values for each key, and we set them in the variable item, and then we can access the quantity on that item. And once we've accessed all of them, they are all set in a list, and we sum all of them up and we have the total quantity. And then finally, we actually call this function right here and we give all the items a value of 5.2. Maybe that's a bit of expensive. You can choose whatever you want. This function doesn't even make any sense. Typically what we would have is we would have the price right here. We would add an extra thing, but I am going to cut this video into two parts. This is a very, very big project. We're already, like in my recording, I'm at the 55.44, 45, 46 second mark. And I decided, like, I was building this and it got way too big. So we're going to continue later on. Yeah, I should have kept that until the end. But anyways, right now when I right click and I run, boom, as you can see, I get nothing. Why? This is very important. This is a very nice question. Why didn't I get anything? Well, of course, because I returned the total quantity. So I actually need to print this out. So now I should get 154, and of course, wow, that's very nice. It actually, there was no floating point. So again, I hope you enjoyed this. Is kind of advanced, especially if you don't know list comprehension, but again, I've linked the videos. You should watch them, you should understand them, and there we go. Whoa, oh my god, that was a long video. Ladies and gentlemen, thank you so much for watching. I hope you enjoyed. If you did, leave a like. If you have any questions, you can always leave them in the comments. Subscribe, all of that good stuff. Again, as I was rumbling around and mumbling inside of the video, I was creating this project and it started to balloon and get bigger and bigger and bigger and bigger. So I decided to cut it in the middle and then continue on a second part, which is going to be right. In this one, we're going to be continuing our functions inventory system Python exercise. That was a long one. And we're going to be covering the following topics. This is a continuation of a previous video of a part 1 that we started because I felt that that part was ballooning out of control, so I had to cut it in the middle and continue it right here. And I say that in that video, you can watch it somewhere around. Now you don't have to watch it. I'm going to provide all the code from that exercise in here so you can use it and continue fresh. But I do recommend that you watch it just so you have an idea of where we were and where we are going to. So if at any point you feel that you're enjoying the contents of this video, make sure to slap that like button because I need to beat any algorithm that's out there. Let's go ahead and get started. Okay, so as always, I'm going to give you the guide of the inventory system so you can do it on your own. If at any point you feel that you're stuck or you don't know, you can always go to where I finished that particular part of the guide or of the system, and then you can continue on from there. But the most important thing is that you try to do it on your own as well. So first of all, you'll need to create a new Python file called basic inventory system and copy all the code from exercise 6 into this one. Now, onto this one. Create another Python file for exercise 7 and import the basics inventory system as the inventory system. If you don't know how to import, again, I recommend that you go and search for it. Very important thing to know about Python. Next, you're going to create a new variable that is the inventory and set it as the inventory from the inventory system. Remember, the basic inventory system that has the code from exercise 6 is imported as inventory system. So you'll need to get the inventory from there and set it in the inventory right here. Next, you'll need to create a new function that is going to be generate restock orders that checks all the items that are under the minimum stock. And for such items, orders a quantity that will double the minimum. So you need to get the minimum, double it, and then order an amount that will make sure that the final amount will be double that of the minimum. It simply returns a dictionary. Oh, by the way, it does not modify the inventory in itself. It simply returns a dictionary with keys being items and name item name and values the amount that you order. So this generates a restock order. It does not actually restock your inventory. Then you'll need to create a function apply restock orders that takes in a restock order dictionary that is generated right here and actually modifies that inventory. And then finally, you'll need to create a function that writes the inventory into a JSON file with the proper indentation. If you don't know how any of these works, if you don't know how files work or functions work, and you don't know how to read and write to JSON files, then I'm going to link all the videos somewhere at the top. You can go watch them. So go ahead, pause the video and try to go through the program guide. Okay, so as you can see right here, what I did is I created a new Python file that is the basic inventory system. And what I did is I copied everything from exercise 6 into this basic inventory system. The reason I did this is because when I have a file that is exercise space 6 space dash space function space inventory, you know what I mean. When I have spaces, I cannot import it. It will now not allow me. So now when I try to import, for example, if I try to import exercise 6, it just does not work. So instead what I did is I created the basic. So now I can import the basic inventory system if it allows me. For some reason it's just stuck. Oh, there we go. So import, now I have the option to hit tab to select the basic inventory system. If I try to get exercise, it will not work. Only the basic inventory system as inventory system. And there we go. Now we have access to it. And inventory, it seems that I've written something incorrectly. There we go. Inventory system. So in this line of code, we're importing a module that we created named the basic inventory system and giving it an alias that is inventory system for us to use throughout the program. This means that instead of having to use the full name basic inventory system every single time we want to access a certain function or a certain variable from it, we can simply use the shorter and more concise name of inventory system. So again, now instead of having to copy all this code and put it in exercise 7, so now we have, right here we have over almost 100 lines of code. If we copy it and put it all in exercise 7 and then start adding functions to it, it's just going to clutter our code and it's going to make it harder for us to go through it and diagnose it and just search for certain function. Instead, now what we can do is we simply import the basic inventory system and we can use everything that's inside. But keep in mind, now if I right click and I run, and notice I'm running exercise number 7, I'm going to close the projects over here because I just wanted to show you how the inventory system is created. I'm going to close it down. I'm going to close exercise number 6. I'm just going to keep these two open. And notice when I ran exercise number 7, I got a certain output. Now we don't want that. This happens because when I imported exercise or imported the basic inventory system, you'll see that I imported the inventory. I imported the functions like the search, the list, the remove, etc. But I also imported these lines of code right here that actually do something. So we run every single line. So I'm going to select all of these and hit Control // on a Windows. On a Mac, it might be different. I'm not entirely sure, but you can search or Google it just to find out how you can copy comment out multiple lines in PyCharm or IntelliJ or in the IDE that you're using. So now when I comment these lines out, these lines that test out the functions, when I right click and I run right here, you can see that I don't get any output, but I can access for files and variables from the basic inventory system. Okay, so in this line of code, we are accessing the inventory attribute or object from the inventory system module that we previously imported and assigned that inventory to the inventory variable, local inventory variable. Essentially, this makes the inventory from the inventory system, that is the basic inventory system right here, which is this inventory, now accessible in our current script. And I can close this down because now we have this inventory, and let's go ahead and print it out just so we can see what's actually inside. Right click and run, and you can see that we have apples with a certain quantity, certain minimum stock. This is a dictionary where we have the apples as the keys and the values of each key, another dictionary that contains the quantity and the minimum stock. Okay, so in here we define a function named generate restock orders that does not take any parameters but works on our dictionary and returns a dictionary as well. So inside, as you can see, I've just added some code or some lines or some strings to describe what this function actually does, and as you can see, it returns a dictionary. Inside, what we did is we first created the restock orders dictionary. This dictionary is going to store all the items and their quantities that we need to order later on. Next, for each item in the inventory right here, using this for loop, we check if the quantity of that item is less than the quantity or the minimum stock required. Now remember, the dot items accesses the or returns two things. It returns first item, it returns the key, and then it returns the value. But remember, the value in here is a dictionary in of itself, so we access the quantity key and we check if that key is less than the minimum stock, and if it is, then we create the order quantity in here that is going to be equal to the minimum stock multiplied by 2, and then we remove the quantity that's already there. Remember, I told you whenever we want to restock something, the eventual or the eventual calculation or the eventual stock that we should have should be double that of the minimum stock. Now if you didn't do that, maybe it wasn't 100% clear, that's okay, don't worry about it, but as long as you were able to get to this line, make these checks and go through each and every item. After we do that, we use the item that we got, which is the key from the inventory system. We use it as another key for the restock orders dictionary in here, and we set the value at that key to the order quantity that we calculated right here. And finally, we print out a statement saying that this is the item that we restocked and this is the amount that we restocked it with. So let's go ahead and test this one out. So I'm simply going to say that the orders are equal to generate restock orders. If I right click and I run, I don't get anything printed out. Why? Because I don't think there's anything to actually restock. So what I'm going to do is Alright, so in here what we did is I used the inventory system module and I called the function add item, and then I added an apple and I added a quantity of 20 with a minimum stock of 10, cherries with a quantity of 40 and a minimum stock of 60. So this should appear whenever we generate a restock order, and I did the same for pineapples. As you can see, the minimum order is 30. And if you're thinking, okay, what is this function in the first place? Again, I told you that you should watch the previous video, part 1. If you haven't, if we hold down Ctrl, you can see that we can use these as links. And if in any case, I can simply hover over this, as you can see right here, and boom, there we go. Name, quantity, and the minimum order. But if you actually want to go to that script, you can click on that and boom, it takes you to the add item in the basic inventory system. How cool is that? Anyway, as you can see right here, we also have the basic information that we wrote about that function. Right click and run, and boom, 20 apples were added. The total is 70. Cherries added to the inventory, now 40, 10. And then when we called upon the restock order, we said that cherries and the order quantity should be 80. Now the minimum is 60 and we already had 40, so we need to have a total of 120. But if we order 120 and we remove 40 from it, that is where the 18 number came. So everything is working perfectly fine. But there is one more thing that we can actually do in here, and that is instead of putting this into a variable, I could actually print out the generate restock order. So now if I right click and I run, you can see that I have this output in here as well. This is the actual dictionary. So this is a function that prints something out, something that we've seen before, and it returns a value. How about that? I think this is the first time that we see, or especially in this exercise of the inventory system, that we see a function that does both. Okay, so as you can see in here, we create or we define a new function that is the apply restock orders that takes in a single parameter that is the restock order, and it should be of type dictionary. And then the function returns nothing. Now, inside of the function, what we do is we iterate through each item in the restock orders, and we do the same thing that we've done in here by applying the dot items. What does that mean? It means it returns again a key and a value, and that value comes from here. So what was the value in here? Remember, first we have the item and then the order quantity, so that is an integer. First thing that we do is we check if the item is actually in the inventory. That is the first step. So if the item is found, then the function adds the order quantity from the restock order to the item's current quantity in the inventory. So if the item is already there, it means that we should get that quantity and increment it. This is the plus equals, that is the increment. I've already explained this many times, and we increment it by the order quantity. The order that was here, remember, it was an integer from this function. Very important. Once we increment that, we simply print out that we've applied a restock to that item and its new quantity is the following. After we finish that, I wrote these two lines of code right here. So in here, I should have orders, that is the generate restock orders. Make sure you don't forget these. And notice I have a print just to separate from other lines, apply restock orders, but we have an error. Why? Because this needs to have some kind of dictionary that is the orders that we've already created right here. And then we also separate this where we print out the list of inventory so we can see all the new items. So when I right click and I run, you can see right here that first of all, we had a restock of cherries, and then we had a restock of pineapples, and in here we actually applied it to the cherries, so now we have a total of 120, and we applied it to the pineapples, so we have a total of 60. Those are the double of the minimum stock that we talked about. And when we print out the list's inventory, we can see that we have 70 apples, just like we had right here, and the minimum stock is 10, cherries 120, pineapples 60, so everything works just fine. Okay, so as you can see right here, I created a new function that is the save inventory to file. Before we continue on, something that I did was create a new directory in here. So when I right click, new, you can see that I create a directory, which is just a file, but in the context of a Python project, we call it the directory, and I called it specifically exercise 7-inventory system files. Notice that it's the same name right here, and make sure that this directory is in the exact same directory. Remember, we have code, and that directory contains all of the exercise files, including exercise number 7 and including this directory. So keep that in mind when you're creating the directory. Don't create it on the outside, otherwise this will not work. So in here we defined the function and we defined an optional path. So remember, we could have specified a path, but we created an optional one. This is a default value. We've already covered that a lot. Now in here I should add an R. Why? Because we need it as a literal, because this is a string. So we need to make sure that it's raw. This R star stands for raw. Whenever you're trying to write a link as a string, or you want a directory file as a string, you need to add the R behind it to make sure that this backslash is not interpreted as a special character starter. If you don't know what all of that is, again, you should watch the variables video that I created, and the reading and writing file video I also mentioned before, or maybe I'm gonna mention it somewhere right here. Now this function begins by opening the file specified by the file path. So this is the file path that we received, and we open it and we use the write mode because we're using the W in here. Then we use json.dump method inside that allows us to write all of the contents of the inventory dictionary to that file, formatting the JSON data with an indentation of 4 spaces for readability. And I'm going to show you what happens if we remove this indentation. This is very important. If you didn't use that, don't worry about it. That's not a big problem. It's a little bit more advanced. So effectively, what this does is it serializes all the information that's inside of the inventory dictionary into the JSON formatted strings and saves it to the file. After we've done that, we just print out a simple inventory save to the file. So right here, again, I'm going to print out a simple print just to separate things, and I'm going to, where is it? Save to inventory file. So save inventory file, the path is already there, and notice right now inside of the exercise we don't have anything, but when I right click and I run, boom, everything is good. You'll notice I have a new chevron. Is that a chevron? I'm not sure. Inventory right here, as you can see, boom, 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 inventory saved to a file. So I'm going to close this down, open up the inventory, and boom, look at that. All of the inventory that we've created is now saved in a .json file. We are professionals. Now let me show you what would happen if I remove these indentations. So if I remove this, right click and run again, and if I open up the inventory file, notice how they are printed out. Not very nice. It doesn't, or at least it's not as good as the one that we saw before. Now I recommend that you play around with these indentations. Maybe 3 is enough, maybe 2 is enough for you to make sure that it looks beautiful, but I found that 4 is the best. Right click and run, and you can see that our inventory looks very, very nice. Okay, fellow Python programmers, congratulations on making it this far. That was a big one. We've covered a lot. We are in the advanced territory when it comes to creating functions, when it comes to working around dictionaries, and of course when creating JSON files. Now it's time for you to test out your knowledge with a bit of a challenge. And remember, the goal is not to do every single step in the challenge properly. It's to try your best and apply the knowledge that you've learned and that you know. And you can always come back and watch the video with me, and you can always leave questions in the comments below. But anyway, let's go ahead and look at the challenge. Okay, so as you can see right here, you need to remove and analyze the inventory. First, you'll need to create a new JSON file that is the advanced inventory. So remember, you need to create a JSON file. And what was the type of JSON file? It was .json. So you'll need to create an advanced inventory that is JSON file in the exercise 7 directory. Remember, the new directory that we created, and add all of the information I provided you. Analyze how that data is structured. So remember, JSON files are very similar to dictionaries, and I've provided you with some data either in the description or the pinned comment. Copy that, put it in a .json file that you create yourself, and then analyze how that data is structured. So what are the keys? What are the values? Is there something deeper in there? Are there embedded dictionaries inside of these values? All of these things you need to figure out. Create a function load inventory from file that takes an optional file path. Again, remember, optional. File path, open up the file and loads or opens up the file and loads all the data into a global inventory variable. Then you'll need to use the try except blocks to avoid any file not found errors. Global variables are something that I still did not explain in any of my videos, but it's something that's very crucial, and I found that this is the perfect opportunity to teach you that. So I don't have any videos to link you to that, but again, you can search for that. That is the beauty. This is the power. This is where you have to be on your own and find out how you can work on a global variable. It's super simple. Don't overcomplicate it. A quick Google search. You can even ask ChatGPT, but don't ask it too much. Don't ask GPT for too much info, because it can just do everything for you, and that's not the point of all of this. And finally, the try except block. This is something that I explained again in the reading and writing of the file video that I linked somewhere around. Create a function inventory report that takes inventory dictionaries and for each category prints out how many items there are, their name and the item quantities and the minimum stock. So this is just a report of said inventory. And remember, you'll have to use the advanced inventory that I provided you. So again, this is working around the data that you've imported. Create a function supplier contact list that takes the inventory dictionary and then prints out a list of suppliers with their contact information and their given inventory. So each supplier should only be shown once. So you'll see, once you analyze the data from the advanced inventory that I provided you with, that there is something called a supplier, and some items have the same supplier. So you need to make sure that a single supplier is not printed out twice. Very important. Finally, create a function that is the cost and value analysis that takes the inventory dictionary. This function prints out the total cost and the potential revenue. Assume that each item can be sold for a 50% markup over its cost. I apologize for all the small mistakes that I did in here. As I was writing these, I was more focused on the actual content instead of making sure that every single English word makes or grammatical. I apologize for that. That take inventory dictionary. Takes. Sorry for that. But anyways, I hope you get all the points. It's not easy. All of these are actually, I think, in my opinion, kind of hard. If you're a beginner, it's very hard, but stick with it. Try your best. As you're watching, if you find yourself very, very stuck, watch my video to that point and then come back and try to continue from there. Do your absolute best. Pause the video right now and go do the challenge. Alright, so in here I'm going to right click on the directory that I created and create a new file. And that file is going to be the advanced, advanced inventory.json. And I made sure to make it .json. And by the way, we can have spaces because this is not something that we're importing. This is a file that we're opening. So I can have a space, but the most important is .json, so that it's a .json file. How did I know it's a JSON file? Because it has the same symbol for the inventory JSON file, which are these two brackets. Then I'm going to paste the information that I provided you with, which is this sort of more advanced dictionary. So let's take a look at what we have in here. So first thing you'll notice is that we have this key, right? This is where the first key starts. So it is fruits. And then the value is a list. How did I know it's a list? Because I have the square bracket. And if you're using PyCharm, you can see that this is the entire list and it stops here. And then we have vegetables. And then it has this list which ends right here. So let's go back to the fruits and let's understand what we have inside. So the key is fruits, just a string, normal string. Its value is going to be a list, and inside the actual items of, or each element of those or of that list is going to be a dictionary. How did we know it's a dictionary? Because it opens up with the squiggly line or a squiggly bracket. And inside of this dictionary, we have key value pairs. So we have the name, Apple, supplier, its value is another dictionary, and then inside we have name and the contact, which are the name of the supplier, and then the email of said supplier. Then we have price, quantity, minimum stock, and it seems that it is the same for everything else. Then we have vegetables. Again, the vegetables has value of list, so the list is its value, and inside of that list we have 2 dictionaries, and each dictionary contains key value pairs, name, supplier, price, quantity, and the minimum stock. And they seem to be exactly the same. There's no difference. Excellent. So again, let me take you through this. This is dictionaries inside of lists, inside of dictionaries. Kind of complicated, seems like very complicated, but once you understand and you diagnose how everything works, it is pretty simple. So we have a dictionary. We start off from the very top. Dictionary, key, value, that is a list. Each item is another dictionary, and each dictionary inside contains key value pairs. You have to understand this diagnosis of the data that you receive in order to properly go through it. Okay, so in this function, that is the load inventory from a file, we use the optional parameter file path to specify the location of the inventory data, and by default it's going to be, of course, the exercise 7 file, advanced inventory.json. We start by attempting to open the file in the read mode. Why did I say attempting? Because we use the try except block, and this is very important when you're working with opening and closing files, because if there's an error, you can corrupt the data that's in the file and just destroy everything. And in here, starting. Then after we attempt, inside of the try block, we open the file with the open method, and we open it in the read mode because we use the R, and then we have the file. Now inside of this with, we define or we declare inventory as global. This will allow us to modify the global variable within this function. So inventory right here is a global variable, right? And we cannot access it. There's no way for us to access it. If I remove this, we don't know which inventory we're talking about. We're creating a new variable within the function. But when I declare inventory as global and I write the global statement right here, so the global statement is a declaration which holds for the entire current code block. It means blah, 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 blah. You can read all about it, but basically what it does is it says inventory is global, which means I'm actually changing the inventory that I've declared right here. This inventory belongs to all of my functions, and when I say global inventory, it means I'm modifying it globally for all other functions. Now, this is not something that's very good, especially when you're working with tons and tons of functions and you have a lot to work with, but for now it's a temporary solution. And then we load all the data from the file, from the advanced, into that inventory that we have, and finally we print out that the file was loaded. Now if we don't find that file, we start off with a empty inventory, and we set it to just be nothing, because we want to make sure that this does not cause errors down the line, because we are going to be trying to access values from it, and if we don't have anything at all, we're just going to get into errors. So this is the function that we have. Let's go ahead and test it out. So right here at the bottom, even though I have to get rid of everything from the top, but I just wanted to show you, if I load the inventory files and I print out the inventory, so notice I didn't return anything from this. This is the power of using the global inventory. Instead of returning and setting it to the inventory, I simply adjusted the global variable inventory. So right here, print out the inventory, right click and run, and boom, there we go. This is my inventory. Of course, it looks extremely ugly, but with time we are going to be able to access things from it. And also, since we are not going to be using any of these anymore, I'm going to comment them out. So select all of these, hit Ctrl//, select these two lines, hold down Shift Alt and use the arrow keys to move them to the top. So now we are working on our advanced function only, or our advanced inventory only. One more thing, if I change this or I just remove an I, this is a good example of, you can see that there is no error. So we try to open a file that does not exist, but instead of getting an error, we simply get a warning message, and we start off with a simple inventory. So just to show you why the try except block is very, very useful. Okay, so in here we define a function named the inventory report that takes in a single parameter that is the inventory, which in itself is a dictionary. And this function does not return anything. That's why we have the none right here. Initially, what we do is we print out just a heading that says this is an inventory report. That signifies that we're starting with a report. I'm also going to add a \t in here just to add a bit of indentation. This is a special character, something that I described or explained in the variables video. Now, what we do is we start off by iterating through this inventory dictionary, and we use the .items as we've done many times before. This again goes through every single key and value. Now the keys we set as categories. Why? Because in the advanced inventory we have fruits and we have vegetables, which I called categories. You can call it whatever you want. And then inside we have the lists. So the items right here, remember, are lists. What I do is, first of all, I print out the category and I print out the total items. So how many items I have. So remember, right here I have a list, and for example in here I have 3 dictionaries inside of that list, which means that I have 3 total items. So the length of the fruits category is going to be equal to 3. Correct? And then I access each item inside of these items, and then remember, what is this? What should be its type? It should be a dictionary, because each item in that list is a dictionary. So I access that dictionary and I access name, quantity, and the minimum stock of said dictionary. Finally, let's go ahead and call this. So I print out the entire inventory right here. This is just for testing. We don't need it, but I just want to do it anyway. And keep in mind, you do have to load the inventory before you have the inventory report. And then I'm going to have the inventory report, and I'm simply going to use the inventory, right click and run, and boom, this is the inventory report. How cool is that? First we have the category, which is fruits, and the total item is 3. Inside we have apples, bananas, and peach, and then a second category that is the vegetables, and we have 2 items, carrots and broccoli, with their quantities and minimum stocks. Holy moly, let's look at this big function. This is one of the most complicated, I would say, but it is also the most thorough way that we were able to go through a dictionary. So because we're accessing a dictionary, and then we're accessing a list, and then we're accessing a dictionary, and then we're creating a dictionary from all of that. So let's dive in. First of all, I made a mistake in here. This is an inventory. This should be an inventory. Excellent. So now we have everything looking good. First of all, what we did is we defined the function that takes in the inventory that is a dictionary, and it returns nothing. Next, we print out that we simply want to supply, or this is the supplier context list. We create a new dictionary that is the supplier, where we just initialize it. This dictionary will store the unique supplier names as keys and their information. This ensures that each supplier is only printed out once, because as I told you, we don't want multiple suppliers to be printed out. We then iterate over the inventory's dictionary with a nested loop. The outer loop accesses each category and its items, while the inner loop processes the individual items within that category. So this is why we're using two loops or nested loops. And if you don't know how loops work, or you don't know how nested loops work, I'm going to reference the loops video somewhere around. For each of them, we then extract the supplier's name and contact information using the supplier key right here that we have, which in itself is a dictionary that contains the name and contact. So as you can see right here, each item is a list, and then we check if that, if this is the item, then we have each item, and each item is, once we access the supplier, it's a dictionary right here, supplier, because we're working on a dictionary. Then we get another dictionary, so we have to use the name again right here to access the name, which is, for example, orchard, I don't know. And then what we do is we check if the supplier name is not in the suppliers that we have right here. Then we append the dictionary suppliers with the supplier name, and we set it to the item supplier, and we have the contact. This is going to be the value of each new item that's added to the supplier dictionary. Whoa, before I redo that, before I re-explain it, finally, this should be the easiest step. We again go through the suppliers dictionary that we have right here, which contains the name and the contact, and we print them out. I'm just going to test it out just to make sure that everything works fine. And once we do that, I'm also going to re-explain it because it's a big one. So right here, inventory, right click and run. And this is the supplier contact list. You can see that each one is only mentioned once, even though we have 3 plus 2, we have 5. And I don't think we had overlapping anyways. Yep, we didn't have any overlap. Anyway, what I'm going to do is I'm going to copy it. This is a mistake on my part. Let's paste it right here. And I'm going to redo this, so right click and run. And as you can see, we only have 4. Excellent. So we don't print out that we don't print out the tropical fruits twice. We only print it out once because there is overlap. We have 5 items, we have 4 suppliers. Quite an interesting oversight. So before we move on, let's go through this again. So we get the inventory. That inventory is a dictionary. So we access the category and the items. The items, again, right here. Let me maybe put it up right here on the right hand side. Maybe that would make it slightly easier. So again, category, items, category. Each items is a list. So we go through every single item in that list. So this item, what is it? It's this, and then it's this, and then it's this as well. So each item is a dictionary. So we access the supplier's name using item, supplier, the key right here, supplier, and it's a dictionary in itself. So then we access the name. So now we have the supplier name. And because we only want to print out each supplier once, we check if that supplier name is in the suppliers already. If it's not, so if not in suppliers, then we create a new item inside with the supplier name as the key, and then we set the value to the item supplier contact. So this is still on the same item, and that is how we print these out. I hope that was as thorough as possible, but we have to move on to the last function. Okay, so as you can see right here, we define a new function in here that is the cost and value analysis. And this function does not return any value. That's why we have none, and it takes in the inventory dictionary. And of course, upon calling the function, we create 2 variables in here, or we initialize two variables in here to 0, which are the total cost and the potential revenue, because we want to go through every single item and accumulate the total cost and accumulate the total potential revenue from selling certain items. So the function then iterates over each category in the inventory using a for loop using the .items. We've seen this so many times, especially in this video. I'm not going to go over it, and I access every single item in the items. Why? Because again, as we've seen before in the advanced dictionary, each value of each category is going to be a list, so we access each one in the list. An item is a dictionary in itself. So then we access, or we want to set the cost, so we access the quantity of each item and we multiply it by the price of said item. So now we have the cost, and then as I told you, the markup for each or for selling each item is going to be 50%, so we have to multiply that cost by 1.5. So we calculate the total cost, we calculate the total revenue of each of those items, and then we print it out. And I don't think there's anything too complicated, especially if you were able to understand this one. The cost and value analysis is much simpler. So once we have all of this, we simply print it out, and I called it right here. So I right click and I run, and boom, there we go. The total cost is 255 and the potential revenue is 382. And you might be wondering also why I have this the .2f. This is to indicate to Python that I only want the last two, or I only want 2 digits after the floating point. If I remove this, I might potentially have... Okay, so in this example, I don't have anything, but sometimes I might get 17 numbers after the floating point. That's why I indicated that I wanted .2. So there we go. This is the cost and value analysis. Okay, fellow Python programmers, I'm at the 1 hour and 5 minutes mark, and I'm so tired, but I'm so glad that we went through this. If you understood everything in this video, and especially if you understood the supplier contact list, you have unmatched skill in going through dictionaries. You have unmatched skills, or you have a big arsenal in your ability to create functions with parameters and arguments and return values and printing, and oh my god, you have so much info. And now you're also a master of working with directory files, with .json files, and going through data. So if you were able to go through this video and understand, I'm gonna say 60, maybe 70% of it, you are good to go. You are doing incredibly well. I'm tired. I don't know what we have next, but it's probably going to be Hey fellow Python programmers, this is a part of the video that I never wanted to do, but nevertheless it has to be done, and you'll know why in just a bit. After 58 minutes of recording and having my throat very sore, because I even mentioned that at the end of this video, I stopped recording. I pressed stop on all of my devices, and then as I was listening to the voice quality of this video, I realized that I was not using this microphone. I was using the microphone of my laptop, which is a huge disappointment because the microphone of my laptop is very bad. So I was thinking, should I re-record this? I have 58 minutes, so this is not a small video. It's 1 hour of 100% concentration, and it really takes a lot out of me. And I just want to let you know that this is not a standard for my videos. I pride myself. I've bought this expensive microphone. I've bought the expensive stand. Everything is really professional because I am an instructor, and I know that delivering good information to the student, is not just about the actual information that's inside, it's also about the method of delivery. The sound quality has to be perfect, in my opinion. But eventually I decided that I will just edit out the video and I just found that the voice from this camera is acceptable. It's not very good, it's acceptable. It's very low, so you'll have to turn up the volume, but in any case, if you feel that it's really bad, I would love to know your opinion in the comments. If it's very bad, I'll have no other choice than just to re-record it. But honestly, at this point, I don't know, maybe you're watching this and my channel blew up, but I barely get 200, 300 views, so honestly, like, so much more work for barely anything, and I don't get paid. I do this for free. I have other sources of income, but YouTube is just something that I do for free, so I just thought, yeah, it's not worth re-recording. Now, if there is a big backlash about this, just let me know in the comments, and I will have no other choice than to re-record it, maybe somewhere down the line in the future, but I just feel devastated about this. And yeah, let me know what your opinion is, and without any further ado, let's jump into the bad sounding video. Sorry for this. Welcome back, my favorite Python programmers, to a brand new video, and in this one we're going to be creating a banking system using object-oriented programming as a Python exercise, and we'll be covering the following topics. So if at any point you feel that you're enjoying the contents of this video, please make sure to smash that like button, because I need to beat any algorithm that's out there. And let's go ahead and get started. Okay, so as always, I'm going to be giving you the banking system program guide first, so you can try it out on your own, and then I'm going to be doing it myself. Again, as I told you before, you can see all the points, you can go test them out yourself. If you feel that you're stuck at any point, you can go watch what I did and then continue on from there. The most important thing is that you always try your best. So, first of all, you need to create a function that creates a random number between 10,000 and 99,000. It will be used to set the IDs of the account holders. So again, every account will have a random number. This is your first task. Next, you'll need to create a class bank account with a constructor that takes in the account holder's name, gives him a number, and initializes a balance. These are going to be the three attributes. So if you don't know how classes operate, I'm going to link the object-oriented video explanation somewhere around here, so you can go watch it before you continue on. But if you already know your way around object-oriented programming, then you should know how these work. This class should have a deposit, withdraw, and the display details method. For deposit, the amount should be positive, same when withdrawing, but also the holder should have enough in their account when they are withdrawing. So these are three simple operations for a bank. You can deposit, you can withdraw, and you can also display all the details about your account, like your name. You display all three attributes of a bank account. Next, you'll need to create a savings account that inherits from the bank account. The constructor takes in the account holder and the minimum balance and calls the super. Again, super, something that we've explained before when working with inheritance. It also has a withdraw that overrides so that the account balance never goes below minimum. So it also has a withdraw that overrides. So this is a withdraw method that overrides the withdraw from the initial bank account, and you have to make sure that now, instead of just making sure that you have enough, you need to make sure that you never go below the minimum, because remember, and a minimum balance. So a minimum balance is introduced into the savings account. Next, you'll need to create a class for the checking account that inherits from the bank account, and the constructor takes in the account holder, calls the super, and sets the checkbook issued to false. So a new attribute in here is added, that is the checkbook issued. So again, this is a checkings account. If you don't know the difference, a savings account usually is designed to save money in there over time. It gives you interest, and just we've added one extra attribute or one extra functionality to it where you have a minimum balance that you cannot go below. And a checkings account is usually intended for daily transactions, so you also get a checkbook with it. If a checkbook is issued, then it's set to true. If it's not, then it's set to false. And you should have should have its own method to set it to true. Only one checkbook can be issued per account. So this is something that you have to keep in mind and figure out. And finally, test out all of these classes and methods. Make sure that everything is working at every single step. So Pause the video right now and go do the program. Okay, so as you can see, this is our first function. We have a simple function called the generate account number. This function doesn't take any parameters, meaning that you don't need to provide it with any information whenever you call it. Inside the function, we simply use a simple random.randint. Now we had to import the random right here at the top. Some of you, and including me, may not have done that, and what you simply did is typed in random, hit dot, and hit randint, and hit the tab, and the random was imported automatically. But I do recommend that you do this manually because not all IDEs are like PyCharm and allow you to do such a thing. But anyway, after, of course, we have this small explanation right here of what this function does. So whenever we are using it, or whenever somebody wants to fetch the documentation for such a function, you can know exactly what it does and what it returns. So finally, we use the randint to get a random number between 10,000 and 99,999, making sure that every account in there is or has 5 digits. That's why we don't start at 1 or at 0, we start at 10,000. And the function then just returns that random number, and this allows us to generate a random ID for each account holder. I'm not going to test it right now. I'm going to instead do it in the class bank account. Okay, so in here we've defined a class that is the bank account. First, we have to initialize the method in it. This is a special method that is called whenever a new instance of a bank account is created. And again, if all of those words like constructor, init, instance don't make sense, you need to go and watch how object-oriented programming works. I'm not going to go into all the details. I'm just explaining these right now for our initial classes. So it initializes the instance with specific attributes, and those attributes are the ones that we provide, like the account holder, and the ones that will be set automatically, like the account number. Well, not automatically, we've done them manually right here in the code, but they get set with, for example, a function, and the balance is initialized to 0. So let's talk a little bit about these attributes. First of all, we have the account number, which is just the ID that each individual account holder will have, and it's a random number that is made up of 5 random digits from 10,000 to 99,900, etc. Now, something that's very important before we continue with the attributes is this self right here, and this refers to the instance of the bank account class on which the method is being called. So, for example, when I will create a new holder of a bank account, then that holder is going to be referenced with the self so that we know that we're setting the account number to that specific instance. And I'll show you and I'll tell you a little bit more about this, and I do go in depth into the self and how it works in the previous video. Nevertheless, let's continue on. And finally, we have the account holder attribute. So this is the attribute, this is the parameter that was sent. So the account holder that was sent is set to the attribute account holder. And finally, we have the balance attribute that is set or initialized to 0, indicating that the new bank account starts with a 0 balance. And of course, the self right here, if you double click on it, you can see that this self right here is the same self that is sent. Okay, so in here I've created 2 methods. I wanted to create the third one, but I felt that I've been typing code for too long and it's time for a bit of an explanation. So first of all, we have the deposit, and second of all, we have the withdrawal. Let's go through them one by one. So inside of this bank account, we've added some functionalities. First of all, we have the deposit method that allows us to add funds to the account. First thing it does is it checks the amount specified or sent to it through this parameter right here, and it makes sure that it's greater than 0 because only positive values can be deposited. If the condition is met, the method adds the amount to the self.balance and prints out a confirmation message along with the new balance. But if the amount of the deposit is not positive, then a warning sign is printed out that only positive amounts can be deposited. Next we have the withdrawal method, and it's similar to the deposit but for removing funds from the account. First of all, it checks if the amount is greater than 0 and does not exceed the available balance. Keep in mind that it can be equal to the balance, which means that you can take your entire account to 0, but you have to have strictly more than 0. This is something that I noticed as I was writing the code, and it makes sense because if you try to withdraw 0 and you already have 0, that shouldn't count. You should have at least 1, which is strictly greater than 0, and then you can withdraw some money from your account. So if the conditions are met, again, the amount is subtracted from the self.balance. So we are something that might have slipped as I was explaining. In here, we're accessing our own balance. So we say self.balance. Remember, this deposit is going to be called on one of our instances of the bank account. So how do we know that we want this specific instance to be changed? We use the self parameter that's being sent, and then we use the self.balance and add the amount or subtract the amount right here. And finally, we have this printout statement just telling us how much we withdrew and our new balance. And if these conditions or one of these conditions is not met, we print out insufficient balance or invalid withdrawal amount. Now I'm going to test all of these out, but first I want to finish the last method and then we will start creating instances. Okay, so this was the last method, which is just to display all the details. Nothing too complicated in here. I simply have a printout statement. So this function, this method, when called, simply prints something out and does not return anything. Similar to the deposit and withdraw, by the way, they simply print things out and modify the attributes. This one, on the other hand, does not modify any of the attributes. It simply accesses the account number of the self, accesses the account holder of the self, and accesses the balance of the self, which is the instance. So now let's go ahead and test these out. Okay, so as you can see in here, I created bank account 1, bank account 2, and then I displayed some information after I've made some deposits for and withdrawals for both bank accounts. So again, what is happening in here? Bank account 1 is created. This is the instance that we're trying to create, and it's of type bank account. I say type because this is the class, and look at this. If I hover over the bank account, you can see that it looks as if it's a method or a function that's being called that takes in the self and the account holder. So now bank account 1, when we say bank account 1 dot deposit, when we say bank account 1 dot deposit 100, this self right here is going to be the bank account 1, so that when we deposit, only the balance of bank account 1 is changed. Not that of bank account 2 or bank account 3, it's that of the bank account 1. This is why the self is so important, and this is the whole point of using object-oriented programming. Anyways, I've deposited 100, deposited another 100, we should have 200, then withdrew 50. And I did the same right here, but I also tried to deposit minus 30 just to make sure that we can withdraw. I'm also going to try and withdraw in here again and try to withdraw maybe like 780 just to see and make sure that the withdrawal works. So right click and run, and boom, deposited 100, new balance is 200, withdrew 50, now the balance is 150. Right here you can see everything displayed properly, and we have random numbers. If you right click and you run again, you can see that these change because these are indeed random. So for Kalen, we deposited 50, deposit amount must be positive, so this is when we try to withdraw minus 30. Then we withdrew 10, we have 490, and we have insufficient balance or invalid withdrawal amount because we tried to withdraw 780 while we have 490. And you can see this is the balance, and I can see that there's something wrong in here. the balance, I probably should add a space right here to make the output, excuse me, look better. So the only problem was that Michael was stuck to the balance, and that is because right here I did not have a space. And in any case, I think even better than a space, we should also add a comma. And if you feel that this line is getting too long, simply hit enter. The placement, or because these are separated into different lines, should not be reflected in the output. Or actually, it will not be reflected in the output. As you can see, they are on the same line. If you do want them on separate lines, you can start adding \n, which are escape characters. Boom, there we go. You can see these are on new lines, but I don't like it like that. There we go. Everything is working good. Now, let's go ahead and create some savings account. And before I go, I want to remove these. These are just for testing because we're not going to be creating bank accounts instances. We're going to be creating savings account and checkings account instances. So these were just for testing, making sure that everything works. I don't like to delete them, so I'm simply going to hit Ctrl//. This will comment out everything. If you're on PyCharm, if you're on a different IDE, the shortcut might be different. Okay, so in this code right here, we've created a new class that is the saving account or savings account, which is a subclass, or it inherits from a already defined class that is the bank account class. This subclass represents a specific type of bank account with some additional rules and some additional attributes. So let's look deeper into it. First of all, we have the init right here. This is the init method that we've already seen, and again, it's called whenever a new instance of the savings account is created. And it takes in the account holder, just like the bank account did. And now it also takes in the minimum balance as a requirement. Now, inside of this init method, we have something called the super.init account holder. And this, basically what it does is it calls the parents class, which is the bank accounts constructor, to initialize the common attributes like the account number, account holder, and the balance. So whenever I say super dot inside of a class that inherits, or inside of a subclass to be more specific, the whatever comes next is the function, or excuse me, the method or the constructor or whatever it is, usually it's the method, of the parent class that is the bank account that is called. So in here, when I say super.init and I send in the account holder, oh, there we go, perfect. So you can see when I double click on it, the init of the bank account is highlighted because it's the same one. It's not this one. Notice that this one is not highlighted. If I double click on it, this one is not highlighted because this init is different than this init. This one, this constructor, is for the bank account. Notice how it's highlighted. So whenever I say super.init and I send in the account holder, it's as if I'm creating an instance of the bank account, but because it's in the init of the savings account, then it's an instance of the savings account. And notice that because it inherits from the bank account, it's going to have its own account number, its own account holder, and its own balance, in addition to the new attribute that we add after calling the super, that is the minimum balance. So this is a new attribute that is unique to the savings account that defines the minimum allowed balance, or the minimum balance that must be maintained in that account. Now, if we go back to the top, you'll see that we have a few new circles that appear right here on the left hand side. And if we hover over one of them, you can see that is subclassed by account or savings account. So this is subclassed, meaning that it now has a subclass that is the savings account. And you can see right here, if we hover over next to the init, is overridden in the savings account. And next to the withdrawal, we also have is overridden in the savings account. So whenever I scroll down, you can see for some reason the init doesn't show it, maybe because it's not really overriding. I don't know if it's not overriding. It does indeed call the init from inside. I don't know the exact nomenclature, that it needs. I don't even know if nomenclature, it's French, nomenclature. But anyways, you can see that the withdrawal, if we hover over it, overrides the method in the bank account. So let's look at the withdrawal and what makes it unique. It's similar to the previous withdrawal, but now we have an extra condition because before we are able to withdraw, we need to check if the self.balance, once the amount that we're trying to remove is removed, still is greater than the minimum balance. If it's less than the minimum balance, that we print out that we cannot withdraw because a certain requirement is not met, which is the minimum balance requirement. So basically what we do is we get our balance, we remove the amount, and then we check if it's still greater than the minimum balance. If it is, then we do super.withdraw. And what is this withdraw? If I double click on it, you can see that it's the withdraw that is in the bank account class. So very important. This withdrawal right here is different than this one. So withdraw is called. Now, why is this called an override? Because now when I have a savings account instance and I call the withdrawal, this one will be called, right? Not this one, not the one in the bank account, the one in the savings account. So this is a subclassing approach that allows the savings account to inherit the general behavior of the bank account from the bank account class while also enforcing additional rules. And this is a very good example of inheritance where you have custom functionality and some extra attributes. Let's go ahead and continue on by creating the checkings account. Okay, so as you can see in here, we created a new checking account class, and this is another subclass of the bank account, which is again tailored to be akin to a checking account. And keep in mind, this is not a professional class. This is not a professional program. Of course, there would be much more differences between a checking and a savings account, but for the purposes of this practice exercise, these are how we have them. Anyways, let's look deeper into what we have. Again, we initialize the init method that takes in the account holder and doesn't take any extra attributes to be set. Again, in here what we do is we call the super init. So we call the init of the bank account and we send it the account holder, and we add an extra attribute that is the checkbook issued, and we set it to, or initialize it to, false. This means that every single checkings account is going to get a checkbook, and one of the rules that I told you about in the guide is that every account should only have a single checkbook issued for them. That's why we have the checkbook issued, because later on we create a method in here that issues a checkbook for every single checkings account. This method manages the issuance of a checkbook for the checking account. First of all, it checks the state of the checkbook issued to determine whether a checkbook has already been issued, if not issued. So whenever we have a not, what we do is whatever we have in here, whether true or false, is converted to the opposite. So for example, if self.checkbook issued is equal to false, not is equal to true, which whenever we add the not to it, which means this entire statement would be true, that means we go into the if statement and we set the self.checkbook issued to true, and we say that the checkbook is issued. But if it's already true, so if this one is true, not true becomes false, and we don't go into this one, we go to the else and we say that the checkbook has already been issued. So now that we have these two classes created with their respective method, let's go ahead and test it out. Okay, so as you can see, we created two instances. First of all, we start by creating a savings account instance for Frodo Baggins with a minimum balance requirement of 500. Then we deposit 1000 into Frodo's savings account, which means that we should increase it by 1000, and next we attempt to withdraw 600. And this transaction should be unsuccessful because the withdrawal of 600 leaves us with 400, which is less than 500. $2,500, which is the minimum of the savings account. So then we separate with a 50 and we create a new checkings account instance, which is Voldy's checking. This is the variable name. I don't make these up. Then we have the name of the holder, or the accounts holder name, Lord Voldemort. We deposit 2,000. We issue him a checkbook. We withdraw 1,500, which should not be a problem because there's no minimum amount that should be kept. And we finally display the details. Now, something to keep in mind in here, notice that we were able to deposit to both these accounts and withdraw, and display to these two accounts, even though, for example, savings does not have the display details, neither does the checking account. By the way, the checking account doesn't even have the withdrawal, and this is the power of using object-oriented programming. You can now create savings account and checking account which inherit from the bank account and use methods that were created in said bank account, like the display details. So instead of me having to copy this and print it in the savings account and then print it again in the checkings account, I can simply create it in the base class, that is the bank account, and then use it on all subclasses thereafter. So let's right click and run and see if everything works. So first of all, we deposited 1,000, cannot withdraw, minimum balance required not met, and then the account number is 28,757. Account holder is Frodo Baggins with a balance of 1,000. Excellent. Next, we deposited 2,000, issued a checkbook, withdrew 1,500, and Lord Voldemort has 500 left in their balance. One more thing I wanted to do, I want to duplicate this line by holding Ctrl D and just put it at the bottom, right click and run, and it shouldn't allow us. There we go, checkbook has already been issued. So everything works fine. Okay, fellow Python programmers, congratulations on making it this far. Oh, we've covered a lot. Well, not a lot, but we've created a very nifty function that gives us a random number. We've created the class bank account, which sets up everything or all the other subsequent subclasses and sets up the methods like deposit, withdraw, and the display details. We've also created two subclasses, one the savings and one the checkings account, and we tested them out on our favorite fantasy characters, Frodo Baggins and Lord Voldemort. Anyways, now it's time for a bit of a challenge where you have to test out a new concept in object-oriented programming. Well, it's not new because you've already watched my previous video on object-oriented programming, but a new one in here that is decomposition, and it's a different way of interacting or interaction between two classes. Anyways, I'm getting lost in my words. Let's delve into the challenge. Okay, so it's time for you to create some transactions. First of all, you'll need to import datetime class from the datetime module. This is something that we have never covered before, so I do recommend that you Google it. Next, you'll need to create a class transaction with a constructor that takes in the amount and the transaction type, which should be string, and the constructor then sets three attributes: the date, which should be datetime.now, the amount, and the transaction type. Next, you'll need to override the __str__ method and return a different output. Very interesting. What is this __str? I do recommend that you go and search for it. Next, you'll need to initialize an empty list of transactions whenever a new bank account is created. So now you are going to be modifying our classes. This is a big hint in here. You should have figured it out on your own. But again, initialize a new list whenever of transactions whenever a new bank account is created. You'll need to append this list whenever a deposit and a withdrawal is made, or a withdrawal is made should have been more appropriate. So you need to append this list of transactions, and remember, what do you send to this transaction? The amount and the transaction type. Add a new method in the bank account that prints out all of these transactions. So a method in the bank account in the base class should allow any holder of this account or savings, whether it's savings or checkings, should be able to see all of the transactions that they've ever made. And finally, make some transactions and test it out. So by test it out, I mean you need to print out all of the transactions that were made after you've made some. So pause the video right now and go do the challenge. Okay, so first of all, what we did is we imported the datetime from the datetime module. So basically, we're importing the class datetime from the datetime module in the Python standard library. This is something that is very typical whenever it comes to creating something that needs a certain time aspect to it, like for example in our case where we need to know at what time these certain transactions took place. So this is how you do it. I've never covered this before, so I didn't mention any video, but you should be able to do research on your own and find out how these things work. Now, this datetime module provides classes for manipulating dates and times. So, for example, this one in particular represents a specific date and time with year, month, day, hour, minute, second, and even microseconds components that will allow us to use these certain components right here to set a certain date at which specific transactions took place. Speaking of transactions, next we define a class called the transaction with the following components. First of all, we have the init to initialize a new instance of the class. Inside, we set an attribute date that will store the current date and time. And later on, you'll see I kept it like this, but later on, I'm going to add to it a special function that will allow us to change how it looks, because you'll see now it's kind of funky whenever you do it. And next we set a new attribute that is the amount. This is the amount, or this stores the amount of the transaction that was made. And finally, we have the transaction type that will store the type of transaction which was made, which should be either withdraw or deposit. Next, we have the underscore, which is another special method in Python classes that defines how an instance of the class should be represented as a string. And do you remember I told you that you need to override the underscore str? And notice when we did create the underscore str, we actually overrode, is that even right here, overrides method in object. Now, why does it override? It's because every single class that you create always inherits from a object class. So if I do this, for example, now it inherits from object. All classes inherit from object, but we don't have to write it every single time. If you don't believe me, you can hold down on Control. This turns into a link, and when you click on it, okay, so it's in here. Maybe if I click right here, excuse me. So you can see define str. This has already been defined, and it's in the class object. So every single class that you ever create in Python always inherits from object, even though we don't have to write it because it's special. So inside of the underscore str, we define how this, we define how when an instance is printed out, how it should be formatted, and I will show you how that would look like. So let's now continue on and let's append or change our different classes to make room for transactions. Okay, so in here we've added a new attribute to the init constructor, that is the self.transactions, and this attribute is going to be an empty list that will be used later on to store the transaction history for every single bank account. So when a new bank account is created, an empty list is initialized to store all future transactions. And we do it right here, not in the init of the savings account, neither in the init of the checkings account. Why? Because this is going to be available to all bank account holders, whether it's checking, whether it's savings. So it's better to create it right here, so it trickles down into all other subclasses. And see how much more convenient this is. We had to create transactions list for both functions or for both classes if we did not have inheritance. So that is the power of object-oriented programming. Okay, so in here, after we've made a successful deposit inside of the deposit method in the bank account class, we then create, or we append our transactions, and notice we did self.transactions referring only to the transactions of the current instance of bank account, and we append it with a new object that we create that is of type transaction, and we send in the amount and the deposit, which is of course the type, and this is the amount that was actually deposited. Okay, and finally in here we have after we have a successful withdrawal, a new transaction object is created with the amount, and this time the transaction type is going to be withdrawal. This transaction is then appended to the transactions list using the .append method, and it's very similar to what we've done in the deposit. And also very interesting, we don't need to fix the withdrawal in the savings account class because of the power of object-oriented programming. Because in the savings account, when we make a withdrawal and it turns out to be good, we call the super withdrawal of, which means the super dot withdrawal is going to be the withdrawal of the bank account. So we only need to fix this or append the transaction list only right here. Okay, so in here we define a method called the print transaction history within the bank account class. And this method is going to, well, print out all the transactions history. First of all, we start off by printing out a header message telling us that, hey, look, this is going to be the transactions history. And then inside we create a for loop that iterates over all these self.transactions, because remember, this is a list, so we iterate over every single one. We set them in the temporary variable transaction, and then we print out the transaction. Now, what does this do? Because keep in mind, this is a list of objects of type transaction. Well, this transaction right here, when we print it out like this raw, this actually calls the underscore str method. Where is it? The underscore str method that we created right here in the transaction class, which then allows us to print out a formatted specific string. And I'm going to show you the difference between an object that's printed out using this underscore str and an object that did not use it previously. So if we scroll down right here to the bottom, I'm going to add another print, and I'm going to add 50. And why am I saying I should be fast forwarding this? Okay, so as you can see in here, we created Harry Potter, their new bank account, with the account holder being Harry Potter. Now, I do recommend, if you want to go deep into testing, that you actually make this a savings or a checking books account to make sure that the transactions do append properly, which, you know what, I do feel that it would be more appropriate, and then we'll just set this to 20 because we don't want to have any errors. We already know that the withdrawal works good, so no need to test that, but we do need to test and make sure that the transactions are recorded even if this is a savings account. But even though we already know the principle and it's correct, just, you always have to test out these things. Anyway, we deposit 100, we deposit 50, we would withdraw 75, we print out the details, and we print out all of the transactions. So when I right click and I run, boom, as you can see right here, deposited 100, deposited 50, withdrew 75, and the account number is 27,176. The account holder is Harry Potter, and the balance is 75. And look at that, the deposits were made in 2024 4/15, which is the date, and now it's 3/29/10.81015, which is not a good number, and I'll show you how we can print it out in a better way. But anyways, you can see that we made a deposit of 100, a deposit of 50, and a withdrawal of 75. How cool is that? Come on. These are all of the transactions that we've made, and they're very good. Now, before we leave, or before I leave you, I just want to save or change how this is formatted. So all that we need to do is, if we go back to where we have transactions, so where we set the date dot now, okay, so now we simply change the way that this is formatted. We have all of the information and we extracted using this modular sign or percentage sign, you want to call it whatever you want. The big Y stands for the year, the small m for the month, and the small d for the date. For the day, and then the big H is for hours, minutes and seconds. So now when I right click and I run, you should see that we no longer have this extra point something something whatever. Now the downside is we don't have the milliseconds, which was kind of cool because now it looks like all the withdrawal and deposits were made in the same or at the same time, which is not very cool. With the milliseconds you were able to see what was happening. So actually let me, you know what, I feel like this one looks kind of better. I mean, just for us, because we're doing this every single millisecond, you can see the difference. No difference at all. All right, so this was much better. Now later on, of course, this will be more prominent when the deposits and transactions are done at different times. Whoa, oh my god, ladies and gentlemen, I can barely speak. As you can see, my throat is sore. I've been talking straight for 58 minutes and now we are done. In the next video, this time I do know what we have. In the next video, we're going to be in this one, we're going to be creating a library management system using object-oriented programming in Python as a Python exercise, and we're going to be covering the following topics. So, if at any point you feel that you're enjoying the contents of this video, as always, please make sure to smash that like button because I need to beat whatever algorithm out there that there is. So, let's go ahead and get started. Okay, so as always, we're going to be starting off with the program guide. This is where you have to try and do your best. I'm going to give you the outline of how the program should look like. You have to go and try to do your best, and it's just important that you actually try to test out your skills, see how it works, see how it doesn't, and then see the solution that I give you. This will reinforce your learning process. In any case, let's go ahead and get started. First, you need to create a class book that has a constructor that takes in the title, author, and the ISBN number. If you don't know what ISBN number, I don't know what that stands for, but I do know that every single book has that number. It's just an ID for the book. Because, you know, sometimes you might have books with the same title and the same author. I don't know. Anyways, inside the constructor, we need to set 3 attributes: the title, author, and ISBN. Of course, this is based on what the constructor has received. And you need to add another Boolean attribute that is the isBorrowed and set it initially to false. So if you don't know how a library works, basically you can borrow books from there. And there we go, we set it to isBorrowed false. Next, you need to create 4 book instances. I'm going to leave some information in the description that you can copy. Next, you'll need to override the __str method and print out the attributes properly. Now, this is something that we've seen before in the previous video, I believe, but if you don't know how it works, I do recommend that you Google it or whatever, use ChatGPT. Don't overuse ChatGPT, please, because you need to learn how to do this on your own. Next, create a class library that has a constructor that initializes a list of books to an empty list. The constructor shouldn't take any parameters. So we're creating a new class that is the library, and the constructor just has a list of books. Keep in mind, I gave you a hint in here, no parameters sent to it. Define a method addBook that takes in a book instance as a parameter and appends that book to its list of books. So a method that adds books. Define a method listBooks that lists all the books in the library in a proper manner. Define a method borrowBook that takes in an ISBN number and sets the books isBorrowed, the books meaning the book that has that ISBN number. So there are some loops that you need to do in here. Loop the books isBorrowed attribute to true. Make sure that the book is there and that it has not been borrowed, because a book that has been borrowed cannot be borrowed again. Next, you'll need to define a method returnBook that returns a borrowed book. The book needs to have been borrowed. So again, some if statements in here that you need to come up with, and that is basically it. And of course, you have to test out all of these methods that you create, all of these overrides that you make. And if you want to create your own instances, add more instances than are available, please do that. Pause the video right now and go do the program guide. Okay, so as you can see in here, first we define the class book. And in Python, a class is like a blueprint for creating objects. And when I say objects, of course, I'm referring to individual instances of the class. If you did not understand any of what I said, then I do recommend that you go watch the object-oriented programming video that I did. I'm going to link it somewhere at the top. Now, you can think of this class or this blueprint as a template for books, where each book will have specific attributes like title, author, and ISBN. And that means that, for example, I can create a book with a specific title, and then I create another book with a different title, and all of these will be instances of the class book. So this is like a blueprint or a template from which all other books will be created. So let's dig into this. First, of course, whenever you're defining a class, finally, you can use the uppercase letter at the start whenever you're defining a method or a variable in Python. It's preferred that you use lowercase as the first letter. In the case of the class, you can use, or you have to use, a uppercase. There's no error, there's no warning, but this is how we prefer to write Python. And in any case, within the book class, we define the special method that is the init. Now, this is known as the initializer, sometimes also called the constructor in Python, and it's called automatically whenever you create a new instance of a class. And the purpose of this method is to initialize the new object's attributes with their initial values. And keep in mind, in here I told you that we need the title, author, and ISBN, but you might have noticed while you were writing the init, when you hit tab to autocomplete, the self gets added on its own. So what is this self? And of course, I've explained this many times, but if you're bored with all of this, you should know that I usually assume that somebody that's watching this video has no idea what all of these things are, so I'm going to explain them, but as we go on, I'm going to keep the explanations briefer and briefer. Anyways, here the self refers to the current instance of the class, and it's how we are able to set the attributes specific for the instance only. So along with the self, we have three parameters: the title, author, and ISBN. And if my explanation of the self was not very clear, just know that it refers to a specific instance, and I will go back to it when we create these instances. In any case, inside, of course, with the self, we've provided the title, author, and the ISBN, and these are the information that we need to provide whenever we are creating a book object. So every time you want to create a book, you have to provide it with a title, author, and this ISBN number, otherwise you will get an error. Now, inside of the init method, we then assign these parameters to instance attributes, and the instance attributes are variables that are specific to each object created from the class. This means that every book object will have its own title, its own author, and its own ISBN. Now, on top of these, so keep in mind that this is an attribute. Notice when I double click on it and hover over it, it says instance attribute. But this one, this is the parameter sent. Notice when I double click on it, this one is highlighted as well. So it's just, we could have called this X if we wanted, and there is no problem with that. But it's just a convenient way to name your attributes the same thing that you've named your parameters that are sent to the init constructor. This is just a convenient way of writing Python code. Now, after we set these attributes, we also create another, or we add another Boolean attribute that is the isBorrowed. And when I say Boolean, it means it's either false or true, that will track whether this book is currently borrowed or not. And of course, we initialize it to a false because when a book is first created, it hasn't been borrowed yet. And that is our book class definition. With this class, we can now create book objects. Let's go ahead and create these books. Okay, so in here I did not write these out myself. Of course, I got that information from online. You can see that we have Python Crash Course, the Automate the Boring Stuff with Python. All these books are very highly recommended, especially this one. I love the author I. Swigart, and I get a lot of my project ideas from him. So I highly recommend that you go and get one of their books on Amazon. But anyways, as you can see right here, these are the instances that we were talking about. So the book is an instance of the book class. So notice when I double click, this is highlighted. So book, what does it take in? It takes in the Python crash course, that is the title. It takes in the author, who is Eric Matthews, who is the author, and the ISBN number, just a random number. It's not random, but we'll just say that it's random. And you can see that where does the self come into play? Well, the self right here, believe it or not, is actually book 1, even though we haven't sent it directly, but it is indeed the self right here. And then we have book 2. This is another instance, and another instance. And I'm going to right click and I will run, and this is the output that I get. Nothing, because, well, we haven't printed out anything. But whenever we create an instance, just so you can see this live, I'm going to print out hi there, because now I want to show you how whenever we create an instance, the init is called automatically. Boom, hi there is called 4 times because we've created 4 instances. Anyway, let's move on. Okay, so in here, after setting up the basic structure and attributes of our book class, we introduce another, or this new special method. This one is called the underscore underscore str underscore underscore, and the purpose of this method is to define how an instance of the book class should be represented as a string. So whenever you print out a book object, Python would automatically call this underscore underscore str method to determine what the string representation of the book should be. And if you've noticed, I always say override the str. Why? Because whenever we define the str, you'll get this circle with the arrow pointing up. When I hover over it, it says override method and object. What does that mean? What we've seen inheritance before. If you haven't, again, I refer you to the previous videos. But what does it mean to override? Whenever we override, it means that we're inheriting from another class. But if you look right here, book just doesn't inherit from anything. Usually when we inherit, there's some kind of class name inside of parentheses right next to the class definition. Well, you can hold down Control and actually click on the str. Oh, excuse me, you can actually, I believe, just click on the circle without holding any controls. Sorry for that. So you click on it and it takes you to this built-in .py. So these are the built-in functions or methods and classes, all of that built into Python. And if we scroll up, we can see that this underscore underscore str belongs to the class object. So every single class in Python, regardless of what it is, whenever you create it, automatically inherits from the class object. So now, for example, when we create the init, we are kind of inheriting from the library manager, we are inheriting from the object class, but it doesn't say the override. I'm not 100% sure why. I need to also check that out. Why does it not say override? But yes, the init is also overridden. The underscore underscore str is definitely overridden whenever you define it. But now let me show you something. I'm going to comment this out. All right, and I'm going to print out book 1. So when I right click and I run, boom, as you can see, this is the output that I get. This is just telling me that it's a book object. But when I uncomment these, so select all of these, Ctrl//, if you didn't know how to do that, maybe your IDE is different, so it wouldn't comment and uncomment things out. So now when I right click and I run, boom, you can see that this is the output that I get. And it's based on what we've done right here, where we say title and we reference the attribute title. Notice that we're using the self. And how did we know so? Right here, book 1. Whenever I say print book 1, it means that I call the underscore underscore str. The self is the book 1, and we've already established that the book 1 has its attribute. For example, title is Python Crash Course. So we print out Python Crash Course. Now, one final interesting thing in here is this line right here. So it says that yes if self.borrowed, else no. And what does this mean? Now, this is something that we've covered before, but just glancing. So let me dock this right here below and explain this a little bit better. So you can see, for example, book 1, the representation borrowed is no. Basically, this is a if statement that we wrote on a single line of code. And this is just for us to save some time instead of writing an if statement from scratch and saying if the self dot is borrowed equals true, then write yes, else no. So this is just a good way to write a simple if statement on a single line. So I'm going to dock it back right here at the top, and we are going to be continuing on. Alright, so now we turn our attention to a new class that we're creating, that is the library. So this class will represent a collection of books, and it's where we will manage multiple book instances. So first, we define the class library, and we start with a constructor just like we've done before. And inside of this constructor library, the only thing that we need is the self. Remember, I told you we don't need any other parameters. And I said inside, I mean as a parameter. We only have the self, and now inside of the constructor, we have a single attribute that is an empty list of books. And the idea is that this list will hold all the instances of the class book that are part of this library collection. So now that we have our books right here, we will be able to add them to our library, and they will be inside of this list. So this is going to be a list of, well, books. Before we go, I just wanted to show you that we can also print out, for example, book 3. So when I right click and I run, you can see that the titles are different, the authors are different, and so on and so forth. Okay, so in here we create our first normal method, that is the add book, and it's designed to take in a book object as its parameter and the self, of course, that represents the library instance. So we are going to have one library instance, but it's okay. It's good to have the self, and of course the self will always be important. So the book parameter is expected to be an instance of the book class representing the book that we want to add to the library collection. Now within this add book, we perform a very straightforward operation of appending our books list with this book object. And remember that the books list is an attribute of the library class that we've initialized in the construction or the constructor right here, and it's intended to store all the books and book instances that belong to that library. So effectively what we're doing by appending this book list is adding more books to our library collection. And after adding the book, we just have a small confirmation message. I like to have that just so we know that everything works. Now let's go ahead and test it out. Okay, so what did we do in here? First of all, we created an instance of the class library, and notice that it does not take any parameters in here because the constructor does not take any parameters. Next, we're adding several books to this library using the add book. So we add the book 1, we add book 2, we add book 3, and we add book 4. And lastly, what we're doing in here is we're adding instances that we've already created. But what we also can do in here is we are directly creating and adding a new book to the library in a single step. And this is done by, well, the following. So we call the add book just like we've done before, but we immediately send it an instance of the book that we've created on this pod. So instead of adding a pre-existing book object, a new book object was created and added within or using the add book. And I just created, I came out of this like Learn Java by Jane Doe. I don't think that's a real book. Maybe there is a real book that is Learn Java, but I don't think Jane Doe is the author. Anyways, when I right click and I run, boom, as you can see, book Python crash course was added to the library, automate the boring stuff, yada, yada, yada. Everything works good. Okay, so in here we create a new method that is the list books that will allow us to list all of the books that we have in our library. So again, first of all, it doesn't take any parameters except for the self that will be the what instance of our library. Inside we check if not self.books, and basically this allows us to see if the list is empty. If it is indeed empty, that means that there are no books in this library, which means we want to print out that there are no books in this library. And then we have this for loop right here, and basically if we do have some books in our library, we are going to print them out. So we go through every single book. Remember that this is the self.books. This is a list which allows us to go through every single item using the for loop. If you don't know how for loops work, I'm going to link it somewhere at the top. And we set every single individual instance of the book into the book variable, and we print out that book. And remember, when we do this, this method right here is called. So let's go ahead and test this one out. At the bottom right here, I'm going to print, and I'm going to say that library.list books. Right click and run, and boom, as you can see, this is the output of all of our books. Now, before we go, I just want to test one more thing out. I'm going to hit Ctrl D, hold down Shift Alt, and use the arrow to try and list the books before we add any books to this library. So it should appear right here. When I right click and I run, boom, there we go, no books in this library. So it's very important that you always test out the if statements that you've created. Anyway, let's move on. Okay, so this method is the borrowed book, or the borrow book. Takes in two parameters, of course the self and the ISBN. Now the method begins by iterating over each book in the books list, which contains all the book instances currently held in the library. Inside, for each book, we check if the book's ISBN matches the ISBN number that was sent to it as a parameter, and that means we're checking if the book actually exists in our library, and then we check if the book has not been already borrowed. So remember, when we use the not, it means that we flip this one over, and we're using an and in here, which means that this condition right here and this condition right here both need to be true in order for us to get into the block of code. Now, speaking of the block of code, inside, the first thing that we do is we set the isBorrowed attribute to true, and then we print out that we've borrowed a book, and we print out which book was borrowed, and we have this return right here, which just jumps out of the borrow book. Why do we do that? Because if we go through every single book and none of them fit this condition right here, then we will print out book is not available or has been borrowed. And what the return allows us to do is once we find the book and we borrow it and we print out that we've borrowed it, we return, which means we jump out of the method and this no longer prints out. Anyways, I'm going to show you how that works, but first I'm going to scroll down right here to the bottom, and I'm going to test this one out. Alright, so I've already set these from beforehand because I don't want to write these numbers from scratch and I'm going to make some mistakes. So basically in here, I'm actually going to maybe move this up like this so that we can compare them effectively right here. Oh, so the library has not been created, so we can't. We have to write them after we've created the library. All right, there we go. So basically in here, what we're doing is we're trying to borrow a few books. So if you see 01359, you can see that it is this one right here. It ends with 52. That is the programmatic programmer. Then we try to borrow another book that is 15 and ends with 9922, which is this one, which is the automate the boring stuff. Then we try this one, which is the Python crash course, and then we try this one, which is a book that we've already borrowed, and I want to see what happens if we try to borrow a book that we've already borrowed. And one more thing, I want to borrow a book that the ISBN doesn't, or that does not have an ISBN that matches the books that we have. And let's see what would happen in this case. So right click and run, and you can see that the book is not available or has been borrowed. Why? Because again, I made the mistake of not adding the book. And you know what? Now that we figured out which ISBN belongs to which one, I'm simply going to print it out at the bottom. And now when I right click and I run, boom, there we go. You've borrowed the pragmatic programmer, you've borrowed the automate boring stuff, you've borrowed the Python crash course. And when I try to borrow the same book again, you can see the book is not available or has been borrowed. And when I try to borrow a book that is not actually in the library because none of its ISBN exists, then we go, also we have this bad output. Okay, so as you can see, we've created another method that is the return book, and you'll notice that I did not write this code, I simply copied and pasted and made some changes. Why? Because the same steps that we need to take to borrow a book are exactly, I already said it, but they are exactly the same as the steps we need to take to return a book, except for some small minute changes. First, we go through, again, the list of books that we have in the library. Then we check if the ISBN is still there or if we have that book inside, which is exactly the same step that we took right here. And now this is where we start having a difference. In here, when we want to return a book, we don't want to check if the book was not borrowed in order for us to borrow it. We need to check that it has indeed been borrowed so that we can return it. So when now we check and book is borrowed, so we need this one to be true in order for us, or we need this one to be true and this one to be true in order for us to go into the if block where we set the is borrowed to false. Why? Because we are returning a book. And then we also print out that we have returned the book title and we jump out, because if we don't jump out, otherwise we print out that the book is not available or has not been borrowed. Why? Because one of these conditions was not met on any of the books that we checked. So let's go ahead and try to return some books. Okay, so as you can see, first of all, I try to return this book, and then I try to return this book, and then I try to return this same book right here, and then I try to return a book that has a weird ISBN number, so I'll just add 12. So when I right click and I run, if I scroll down, you can see that we have returned the pragmatic programmer, and apparently this is not something that we have anywhere, so I'm simply going to copy this because we know that we've borrowed it. I'm going to paste it, and let's see, can we return the automate the boring stuff? Yes, there we go. We can return the automate boring stuff. And one more thing, I want to print out book 1 because we have borrowed the pragmatic programmer, right? The pragmatic programmer is book 4. So I'm going to try to print out book 4, and I want to see the extra parameter or the attribute that is the is borrowed and how it changes. So boom, there we go. You can see that borrowed is yes, and in here borrowed is no because we have returned it. Right here we borrowed it, and right here we returned it. And our library management system is working great. Okay, fellow Python programmers, congratulations on making it this far. We've covered a lot of stuff. So we've created now 2 classes, the book, that was the first class, and then we created the library class as well, and we have created some methods inside of the library that allows us to manage our books that we have, which is great. And we've covered a lot of stuff. We've learned how to work with classes, with instances, with attributes, with parameters, sent to methods in those classes that modify the attributes in different ways, and we've seen how our system is starting to take shape. Now the next step is to add users and add a layer of complication into our borrowing process. So now we don't just borrow a book, we have a user that is registered to every single book that was borrowed to make sure that that user actually returns the book that he has borrowed. So without any further ado, let's jump into the challenge. Okay, so your challenge is going to be to Adding users. First, you'll need to create a new class users with a constructor that takes in the user ID, name, and an email, and create an attribute or create attributes out of these, and also add the underscore underscore str special method to print out that user in a nice way. Inside of the library class, add a new attribute of type dictionary to store the users, and the keys will be the user's ID and the values will be the user's object. Now keep in mind, you'll just need to initialize an empty dictionary inside of that library. Define a new method, add user, that takes in a user object as a parameter and adds that user to the user's dictionary. And again, this is a question. Now, I deliberately left it out. Where should you create the add users? Should it be in the book? Should it be in the users? Or should it be in the library? Try to figure that one out. Define a new method that lists all the users, all the users with their info. Define a update user method that allows us to update a user's name or email. It takes in a mandatory user ID parameter and two optional parameters, name and email. Define a delete user method that deletes a user from the library. And we want to assign to every borrowed book a user from our library. So give the book a new attribute borrowed by and make the necessary changes to the underscore underscore str and also the necessary changes to when a book is borrowed and returned, and the user must now be specified. So this is your challenge. The hardest part is going to be the last one. The medium hard part is going to be figuring out where you should be creating these methods. Pause the video right now and go do the challenge. Alright, so in here we introduce a new class that is the user. This class is designed to represent a user on or in the library, and each user is going to have their unique ID, a name, and an email. And when we define a user class, we have a constructor just like we've had with the library and just like we've had with, well, any class that we've seen so far. It takes in three parameters: user ID, name, and email, and we set the attributes that have the same name as the parameters. As always, this is an attribute. You can see it reflected right here. This is the parameter sent to it. You can see it reflected right here. Following the constructor, we introduce a special method that is the underscore underscore str, and within this method we simply create a formatted string that will include the user's ID, name, and email represented in a simple yet effective way. Alright, so the next step was to add a new attribute to our library that is the dictionary of users. And in here, this is going to be a dictionary to store all the user objects with user IDs being the keys, because every single user will be able to buy or borrow a book and then return it. Okay, so in here we create or add a new method or define a new method that is the add user, and we do it inside of the library. Why didn't we do it inside of the users? Well, because this is where we are going to be managing our users inside of the library. Now, when you're building a more complicated system and there are much more intricate ways of creating a user and books and etc., you would create a separate class that would manage books, that would manage users, but that is for more advanced topics. For now, because we are going to be borrowing, or at least because we have the dictionary users stored inside of the constructor in a library class, that means that whenever we want to add a user, we have to do it inside of the library class itself. So what do we do in here? First things first is we need to check if the user that we're trying to add already exists in our dictionary, and we do it right here. So the add user has a parameter sent to it that is the user object, and that means that every user will have a user ID, and we're going to be using this user ID to go through the dictionary of users. And remember, when we do this, if user.userid in self.dictionary or in any dictionary that we do, that means that we check all of the keys in that dictionary. So we go through all the keys in that dictionary, and if one of them matches, that means that the user has already been added, which means that the user already exists, and we return, which just means we jump out. Now, if we don't find the user already in the library, we add a new entry into that dictionary using that user ID as a key, and we set the value as the user. And if you don't know how dictionaries work, again, I'm going to link the video of the dictionaries somewhere at the top, and you can follow it. I'm not going to delve too deep. We've already covered this so many times. Let's go ahead and test this one out. Okay, so in here we add two new users, John Doe and Jane Smith, with their email and their number. And as you can see, I did not add a pre-existing user. I created the user on the spot and added them directly to the library. So now when I right click and I run, we should see at the bottom that the user John Doe added with an ID and user Jane Smith was also added. Oops, I was a bit quick there. User added with an ID of 2. Okay, so we've created a new method that is the list users. So the first thing that we do inside of here is check if we actually have any users, and that's very important because we are applying this .items method to it, which will cause an error or a warning or a bad message if there are no users. So first we check, are there any users? If not users, that means that the users dictionary is empty, which means that no users are registered, and we return. So we jump out of the list. Now, if it's not empty, if the users dictionary has indeed users, the method will proceed, and each item in dictionary has a key value pair, remember, and with the key being the user ID and the value being the corresponding user instance. And during each iteration, the method retrieves both the user ID and the user, and we do this using the .items. Again, something that we've explained many times when it comes to dictionaries. Basically, the .item returns a tuple that is the user ID and the user, and we unpack them, or actually it returns a tuple that is the key and the value, and in our case it's the user ID and the user. We unpack them into these two variables, or shall we say the temporary variables, and then we print out each individual user. And when we do this, what is being called? Where is it? Right here, the __str is being called because, well, we've overridden that method. So if I scroll down to the bottom right here and I print and I say library.list users, right click, run, and boom, this is the output that I get. Okay, so in here we've defined a new method that is the update user. It takes in 3 parameters. First, it takes in the ID, which is a mandatory parameter to identify which user records needs to be updated. Then it accepts 2 other optional parameters, the name and the email. So for example, the person or the user can provide a user ID without providing the name because they don't want to for example, update the name, they only want to update the email. So they would provide only the name or whatever. They don't provide the email, so the email by default is set to none. This is called a default value for a parameter, and something that we've covered in the functions video. If you want that, I'm going to link it somewhere at the top so you can go and watch it. Now, first of all, we check if the user already exists in the users dictionary. If they are, or they don't, or we don't find it, then we will say that the user is not found and we will return, so we don't go through any of these. Next, we check if the name has been given to us, if the name is something, if name. This basically says if name different than none. which means that a name was provided. So what we do is we update the name. Then we check if email, which means that if the email is not equal to none, then we will update the email. And the way that we do this is, keep in mind, we've already made sure that the user ID already exists. So whenever we say self.user user ID, we find the user with that user ID dot name. So we access the name, because remember, this returns the instance or the object user. Then we say dot name, we access the attribute, and we say that it's equal to the name. And the same thing happens right here, where we access the email and we update the email. And notice this email right here, it's different than this email, because this one is the one that was sent to us, and this one is an attribute. If I scroll up, there we go, you can see this is highlighted. So highlighting, very important. That's why I recommend that you get PyCharm. And finally, we print out that the user was indeed updated. So let's go ahead and test it out. Okay, so as you can see right here, I also want to print out the users. So as you can see right here, I update the 001, which is John Doe. So I changed the name to Jonathan Doe, and I changed the email to update at example. And then I updated ID2 without updating the name, and I simply said that email is only new email. Okay, only new email. Very good. So, and then I listed all the users. So now when I right click and I run, we should see that Jane Smith has the same name but has a new email that is the only new email. And then John Doe is no longer John Doe, they are Jonathan Doe, of course, with a new email. So this is the update users, works perfectly fine. And if you want, you can also test out, for example, 3, which does not exist. And there we go, user not found. Excellent. Okay, so as you can see right here, we define the delete user. Very simple. I'm not going to delve too deep into it, but basically what we do is we check if the user is in the users using their ID. Then we delete that user using the del statement right here that allows us to delete a object from a list or a dictionary or a tuple using this del right here. And finally, we print out that the user was deleted, and the else right here is for this if statement, because if we don't find the user, we print out that we, well, did not find the user. If I scroll down, I'm going to, whoa, we've done a lot. I'm going to test this one out. So this should be pretty simple. Library.delete user and then 001, and I will print out, oops, just duplicate this and print this one out. And I'll just add some spaces in here just to separate things, make them clear, run, and boom. As you can see, we only have Jane Smith. Let's try to delete 3. Boom, user not found. We still have both. Okay, so in here, as the challenge told us, first of all, we created a new parameter or a new attribute, sorry, inside of the book that is the borrowed by, and we set it to none because, of course, at first, the book is not borrowed by anyone. Now in the str, you could have simply printed out or added this borrowed by, but I wanted to do something more fancy. So in here, what I did is I created a new variable that is the borrowed by status. And you can see right here, it's going to be yes if the self.borrowed, else no, just like we've had before. But this time you also have yes, comma, by self.borrowed, which will be added right here. If the self.is borrowed, else no. All right, so very simple, nothing too much in here. Now we need to update the methods. Okay, so as you can see, we have updated our borrow book method. I wanted to keep the old one just so you can make some comparisons and so that I also can show you some of the differences. Now, upon calling the borrow book, you can see that the ISBN number is sent, something that we've done the same before, but now this time also the user ID is sent. Now, if the user is not in the self.users, we print out that the user does not exist and we return, so we don't have anything else printed out. Actually, this one should be right here, so this one is not good. I apologize. This was a mistake. I've been recording. Hello there. I've been recording for 1 hour and 7 minutes and I'm very tired. So expect mistakes at this point. Anyways, let's power through this. Where are we? Yes. So if the user ID is not in the users, we print out that they do not exist and we return. And otherwise, if we do not return, we go through every single book that we have, just like we've done before. We check if the ISBN is already there, just like we've done before. And if the book has not been borrowed, just like we've done before, inside we set the is borrowed to true, just like we've done before. And finally, something that we haven't done before is we also set the book.borrowed to the user ID. Now you might be tempted to set it to the name, but a user ID is more appropriate in such a situation because you might have two people with the same name and that would not work. So you would need the user ID that should be unique, even though we don't reinforce it, or do we? Yes, we do reinforce it because keep in mind, we cannot add a new user with the same ID. That's very important. We do reinforce it. So the user ID is unique to each individual user, which means that we will not have any mistakes in our system. And then we print out that the user with this user ID has borrowed. Now, something that is slightly better, what you can do in here is you can say that the users with this user ID, and we should say self. So self, if I hit tab, it will disappear. So self.users with the user ID dot name, so that we have the name, so the user etc. has borrowed. You can even remove the user to make it more friendly. And finally, we return once the book has been borrowed, or we simply print out the book is not available if we go through every single book and none of these are matching. Or we can also say in here, or has been borrowed. Boom. Boom. This is what I was looking for. I will test this out once I create the return book as well. Okay, congratulations, making it to the final method in here. So return the book. So we go through all the books. It's basically exactly the same, but we add an extra condition in here where before we checked if the book exists, if the ISBN match, then we checked if it has been borrowed, but we also need to check that the book has been borrowed by that user so that we know that that user can actually return the book. So we say that the book has been borrowed, set to false, the book.borrowed by is set to none, and finally we print out that that user has returned that book, and we return, which means we jump out of the method. And in here the book is not available because we have three conditions. So either the book is not available, or it has not been borrowed, or it has not been borrowed by this user. So we have three conditions in here. All three must be true for us to get into the if. If only one of them is false, then this print statement right here is printed out. Okay, so I did not want to write the ISBN numbers. First of all, I don't even remember what these are. I'm not going to go back to the top, but I know that I've checked almost all conditions. So first of all, we borrowed this book. We've already seen this, that ends with 52 by user 1, but I deleted user 3. That's good. So we still have user 3. So user 1 borrows this book, then user 1 borrows this book, then user 2 borrows this one, then user 2 borrows this one, and then user 1 tries to return this one, which they did borrow, and user 2 tries to return this one, which they did borrow as well. And then we are going to right click and run, and we get an error because we have one thing that is required when we click right here. Oh, so this is the old borrow book and this is the old return books. So you have to Ctrl// and uncomment them. Because remember, we've uncommented or we've commented the old return and the old borrow book. That's great. Error, excellent. We learn from our mistakes. Right click and run. And boom, there we go. Right here you can see that the user Jonathan has returned the pragmatic programmer, and he has borrowed the pragmatic programmer. Jonathan has borrowed the automated. Jane has borrowed the Python crash course, and the book is not available or has been borrowed because Jane was trying to borrow a book that was already borrowed right here by Jonathan. So the book was not available. Then Jonathan tried to return this one, and Jane tried to return this book that she did not borrow because that was Jonathan who borrowed this book right here. Boom, boom. As you can see, everything works perfectly fine. Ladies and gentlemen, congratulations on finishing. And congratulations to me on finishing. Finally, 1 hour, 15 minutes, battery running out, voice cracking, very tired. Next video, what are we going to do? Wait, let me check. Welcome back, my favorite Python programmers, to a brand new video, and in this one we're going to be creating a menu manager for a restaurant using object-oriented programming in Python as a Python exercise. And we're going to be covering the following topics. So, if at any point you feel that you're enjoying the contents of this video, please make sure to slap that like button because I need to beat whatever algorithm there is out there. Let's go ahead and get started. Okay, so if you don't know how all of this works, basically as soon as we start, I'm going to present you with the program guide, which you need to follow and try to do your best to create the project or the program on your own, and then you can watch how I do it and follow the steps. And again, if at any point you start creating and working through the guide on your own and you feel stuck, you can always go to where I've arrived, follow the steps, and then continue from there. But anyways, first of all, you'll need to create a class menu item with a constructor that takes in 3 parameters, name, category, and price, and set these 3 attributes. Also override the special __str method. If you don't know how these things work, I'm going to link the video that discusses classes and object-oriented programming in Python. Next, you'll need to create a class menu manager with a constructor that doesn't take any parameters and simply initializes a dictionary of menu items as an attribute. So the second class that you'll need to create is going to be the menu manager that will initialize a dictionary. And what is this dictionary going to look like? Well, this dictionary has a key as category. So if you don't know how dictionaries operate, again, I'm going to link the dictionaries video somewhere at the top. So basically, this dictionary is going to have keys as the categories of the menu items, and the value and its value as another dictionary that has key name and value as the items object. So this is going to be a nested dictionary, so you'll have a dictionary inside of another dictionary, and first of all you'll have the keys as the categories and the values as other dictionaries that have key as the name of the item and the value as the object itself. So we move on. The class should have a add items method that takes in an item and adds that item to the dictionary. It adds the item based on its category, and if the category doesn't exist, a new category is created and the item is added. Next, you'll need to define a remove item method that takes in the name and category of an item and removes it from the dictionary. Define an update item price. Method takes in a name, category, and the new price, and then of course updates the price of the item provided. And finally, well, not finally, there's one more step, but define the list items by category that takes in a category and prints out all the items in it. This is going to be very helpful later on. And finally, the test out the classes and methods at every single step. So pause the video right now and go try to do the program guide. Alright, so first of all, what we did in here is we created a class menu items. If you don't know what a class is, basically this is going to be a blueprint from which individual menu items will be created. Each item will have attributes like name, category, and a price. Or to be more specific, when I double clicked on these are the parameters and these are going to be the attributes. Yes, there is a difference because notice when I double click on the price, this is highlighted, this is not. While if I double click on this one is highlighted because these are the parameters that we are assigning to these attributes. And yes, the attributes will have the same name as parameters. This is convenient for us as programmers or Python programmers, to be more specific. Next, we define the initialization method, also referred to as the constructor, which is the underscore init. And this is a special method in Python called automatically whenever a new object or an instance of a class is created. And it has 4 parameters: the self, name, category, and the price. Now the self is a reference to the instance of the class in itself, and I'll show you when we explain this line exactly what the self means, even though I've explained it so much before, but a lot of people still have problems with it. A lot of people still ask me questions about it, so I'm going to repeat it as many times as needed. Next, we have the name. This is simply going to be a string that represents the name of a menu item, for example, cheeseburger or veggie pizza or whatever. Next, we have a category that is going to be a string that describes the category of the menu item, such as the main course or appetizers, dessert, drinks, etc. And finally, we have the price, which is going to be a float that indicates the cost of a menu item. And keep in mind, this is going to be a float because, again, the prices could be 3.5, not necessarily just 5, 6, 7. They can be 10.22, whatever. Now, inside of the method, these parameters are assigned to their respective attributes, and this means that each menu item created from this class will store its own name, its own category, and price. Then, of course, we also define another special method that is the underscore str, and this method is used to return a string representation of the object, which is going to be very handy for us to quickly print out and check what the attributes of a certain instance is in a very neat way instead of just having to print each one individually. And this method only has the self parameter because it operates on the data contained within the class instance. And finally, we're going to test this out by creating the latte right here, which is going to be of type menu item. And you can see that the name is latte, the beverage is the category, and the price is 3.5. Now, notice right here that this init takes in 4 parameters, right? Including the self, even though the self has a different color, which should tell you that it's kind of different than the name, category, and price. And notice that we only provided 3, which is the name, category, and price. So where's the self? Well, the self is actually the latte itself. So when we say self right here, we say that the latte.name is going to be the name that we've provided. The latte.category is going to be the the latte.category is going to be beverage. Later on, if I create, for example, a burger, the burger is going to be the self, and it will have its own name, its own category, and its own price. So this is how the self works. Okay, so this is a part that I was very worried a lot of students are going to stumble upon. How do we make this or initialize this as a dictionary? Especially the fact that I told you a lot about this dictionary, so you might be thinking, oh, I should have added some stuff in here. I know it's complicated, but these are the things that you need to get used to when working on projects on your own. So we define a class in here that is the menu manager, and again, this class is going to be used to manage multiple menu item instances. It's going to be like a container or a system through which we can add, remove, and modify a item or items on a menu. Next, we focus on the initialization method in here, that is the underscore init, and this is again a constructor of the menu manager class. It only takes in one parameter, that is the self, and as I told you, the self represents what? It represents the instance in of itself. And inside of this method, we initialize only one attribute, that is the menu items, that is an empty dictionary. And this dictionary is going to be used to store menu items. So I've already explained to you how it will look like on the inside, but let me just give you a clearer understanding now that you've seen how a item is created. So the keys of this dictionary will be the category. So for example, we'll have a category beverage, we'll have a category dessert, we'll have a category burgers, whatever. So the categories are going to be the keys right here. And the value of each key is going to be another dictionary where the item's name will be the key and the value is going to be the object in itself. And this will become clearer once I create the add items method. Speaking of that, let's go ahead and do it. Okay, so I just noticed that in the previous section or before I started writing the new code, I forgot to run this at least to test out the latte and at least to test out how it's represented, but it's okay for now. I'm going to run and we're going to see everything. For now, let's go back and see and look at the new method that we've created. So first of all, we have a new method that we've defined that is called the add underscore item, and it takes in two parameters, the self and the item. Again, the self in here refers to the instance of a class that would be menu manager, and the item is expected to be an instance of the menu item. Now, why do I say expected? Because somebody can provide us with an item that's not from this specific class and it will cause errors, and we have to mitigate these errors. But for now, we're keeping things very simple. We're just expecting that this item is going to be of class menu item. And why would it cause errors? Well, because of the first line right here, because what we're doing is we're checking if that category already exists in our menu items. And if you don't know how we can go through the different keys in here, again, you should watch the dictionaries video where I explain this or delve deeper into this. But basically, when we say if item.category not in self.menu items, remember menu items is a dictionary. Basically what we're doing is we're going through all of its keys and we're checking if the item.category is not in it, meaning that this is a new category that we're adding. And if it is a new category that we're adding, then we're going to create a new dictionary for that category using this line right here. And notice that now we are using the item.category as a key in between the two square brackets and creating a new empty dictionary. This is only if we don't find that specific category. Now, if we do find the category, that means that this condition right here is false, which means we don't enter into the if block. That means we come back right here and we add the item.name to that category equals item for a category that already exists. But if we do like this, in any case, this is good because if we create a new category, then we can add that item to that category as we've done right here. And finally, we have a simple printout that tells us that we've accomplished this. So this will allow us to organize menu items not just by their existence, but categorically and by their name, making it easier to access any specific item directly using its category name. So let's go ahead and right click and see what the output looks like. All right, so first of all, we created the latte beverage, which is 3.5. This is because of the underscore method that we have right here. If I comment this out, look at the output that we get. So this is why we use the underscore method. Right click and run again. Boom, very nice. Now in here we add the latte item. That's why it tells us that we've added this latte item. And then we add the coffee beverage. and there we go, it's added. And now when we try to print out the menu manager, or the menu items in the menu manager, you can see that we get this weird looking output. But don't worry, this is not a weird output. This is just because we're not using the __ str. This is indicating to us that we have a dictionary. So you can see the dictionary starts right here. This is the category. This is the key that is going to be the category, and this is the value, or the first value. Actually, this is the entire value right here, and it's a dictionary, and it has its own key that is the latte, and the value is an object, and then another key, and this is an object. So if you're still not sure of the structure of this menu manager or menu items in the menu manager dictionary, please take the time, understand where the parentheses start, where the parentheses end, and maybe if I try to do something like this so that we can see all of it, you can see that we have dictionary right here, one big dictionary, then we have this key right here, and then we have a second dictionary right here. And I do recommend that you create several different items just so you can test things out. Okay, so first of all, in here we define a new method that is the remove _ item that takes in 3 parameters: self, name, category. You already know what the self does. Next, the method checks whether the given category right here exists in the self.menuItems dictionary, and whether the specific name of the item exists in that category. So once we make sure that that category exists, and this is to avoid any errors, because if we try to access a key that's not available in the dictionary, there's going to be an error. So first we check that this category exists, then we check if the name of the item is part of that category, and if both of these conditions are true, that means that we do have that item inside of our dictionary under that category, and we simply delete that entry. And after successfully removing the item, we print out a confirmation message. Now, after removing the item, the method checks if the category has no items left. And this is something that I did not tell you to do, but this is something that you need to start as a programmer, as a developer. You need to start considering these small details, because if we remove all the items from a category and we don't have anything inside of that category, should we keep that category? Well, no, because there's nothing in there. So now we just have an extra entry without any significant items inside, and this can cause problems whenever you're trying to print things out, not just aesthetically, like literally cause errors in your code and prevent you from presenting your menus properly. So now with this if statement right here, if not self.menu, this checks if the category in the subdictionary is empty, and if it is, we simply delete it using the del right here, similar to what we've done right here at the top. Now finally, we have an else statement, and this else statement belongs to this if right here. Notice that they are on the same line of indentation, and this is simply to print out to the user that the item was not found in the category, or maybe the name is not present in that category. Maybe that category doesn't even exist. So we simply tell the user that it was not found. So let's go ahead and test it out. So if you remember, we had the latte right here. So after we print out the menu, I'm going to remove the coffee. So I'm going to do menu manager dot remove item, and I'm going to remove the coffee. I will duplicate this line and add it right here at the top. Oh, so it needs also the it's a good idea. You know what I was thinking now? I was thinking maybe we could remove the item directly. So for example, we could create something right here in the remove item where we just give it the object that we want removed, and we extract the category and the name from that object. But then again, I thought maybe just provide it with the name and category. That might be easier. Again, like for a user interaction, if there's a user that has no idea how these things work, they would simply have two square input on their application where they have to input the coffee and the beverage, or maybe usually that item would have an ID and they enter it and it's removed. But again, we're keeping things simple. So in here, instead of coffee, we provide it with the name, and we're going to provide it with the category that has to be, I'm just going to copy and paste it. So right here, I'm also going to add a print just to separate things. Right click and run. Okay, so everything was added. We have latte right here. And as you can see, the coffee is removed. Excellent. So this is working. Removed coffee from the beverage. Let me duplicate this and let's remove latte as well. And I want to see if the beverage still exists, because now beverage has nothing in it. So when I right click and I run, excellent. The beverage was entirely removed because there's no more items inside of that category. Let's continue on. Okay, so we've defined a new method that is the update items price with 4 new parameters. Well, not new, but 4 different parameters: self, name, category, and new price. These are self-explanatory, so whenever you want to update the items menu, again, you provide it with a name, a category, and the new price that you want to set. And inside, similar to what we've done in the remove items, we need to make sure that this category exists in the menu items dictionary, and we need to make sure that the name is also part of that category to avoid any errors and just, well, to make sure that we have that item indeed. Now inside, we're going to say that the self.menu item, so we access, first of all, we get our dictionary, then we access the category, and then we access the name, or we access the actual item using the name key. And then because we now have, with this accessing right here, we have the actual object, so we can access the price and we can set a new price to that object. And finally, we print out the new price. And otherwise, if we don't find that object, we print out this statement right here. So let's go ahead and test it out. To do this, I'm not going to remove the items, or actually, you know what? I'm just going to do it right here. I'm going to print this out. I'm going to say menu manager dot update item price. So let's go ahead and update the latte. I'm simply going to copy this because it looks exactly like the way we're initializing. And remember, it was 3.5. I'm going to make it into 12.5. This is inflation, ladies and gentlemen. So I'm going to print out latte again, right click and run. And as you can see right here, the price of the latte was 3.5. Now it's 12.5. If I try to print out the coffee, it should stay the same, 2.5 as before. So now I want to add a few more examples right here, a bit more diversity, because currently we only have beverages. So let's add some desserts. Okay, so now when I right click and I run, as you can see right here, let me wrap this up. So beverages, coffee, excellent. So as you can see, we only have one key in the big dictionary, in the outer dictionary, only one key that is the beverage and has a dictionary that contains latte and coffee. We updated the price and we added tiramisu, and we forgot to print it out. So let's go ahead and print it out. Duplicate this using Ctrl D and put it at the bottom because I want to see it right here. Right click and run again. So as we've seen before, beverage right here. Now we have beverage, and notice we start with this dictionary. It goes and closes right here because now we have another entry that is the dessert, and that dessert has tiramisu, and the value is right here. And this is also very important because notice, once we've removed all the beverages, only the dessert is left. All right, very nice. We have everything working properly for us. All right, so this is going to be the last method that we create before we get into the challenge. So right here, as you can see, we define a new method that is the list items by category, and it takes in the self and the category so that we can list everything. What we do in here is, again, to avoid any errors, we check if the category exists in the menu items, and then for item in self.menuitems category.items. And if you're familiar with dictionaries, of course you should be. I mean, we've been working with dictionaries for the past close to 30 minutes, I guess, at this point. So the .items returns two things, or it returns an object that contains two things. It's going to return the key and value. So if I hover right here, oh please, come on, give me something. It does not want to give me anything, but basically it returns the key value pairs inside of that item, and we simply print out each item. And if we don't find that category, we simply print out that the category was not found. So I'm going to print this out twice, once before removing the items and once after. So right here, I'm going to add a print, and I'm going to say menu manager dot list items by category, and I'm going to print out all the beverage, and I'm going to duplicate this and print out all the beverages again, and I'm also going to duplicate this and print out all of my desserts. Boom, boom, there we go. Right click and run, and I don't have a very nice output. So coffee removed, dessert. Okay, doesn't look like a very nice output. So I'm a bit dizzy right here because I can't understand which ones are the menu.list items. So I'm going to remove the printing of menu items. In reality, we would never do this. We would never access the attribute directly and print it out. So now I will right click and run, and as you can see, boom, this is the output that we get. So as you can see, it's a dictionary that returns the key and the value pair. Now again, this is not a good looking value, of course, because it's simply printing out the menu object directly. It's not really representative of the object that we want to look at. So what you could do instead in here is, for each item, you can also, where is it? So right here we can say, for example, the name. So this is going to be the item name and the item in itself. And now this should look a bit better, I believe. Yes, there we go. Excellent. So as you can see, it looks slightly better. Where is it? Right here. There we go. You can see that they are printed out much better, and you can do something even better than this. So for example, right here, so once we find the category and we're printing out, we can print out, for example, category, two dots, and then right here we can say category, and then right here I can actually add a backslash T, Boop, there we go. And you know what? This will indeed look better. Boom, there we go. Right click and run. There we go. So as you can see, the category beverages, we have latte and coffee. And again, like for example, right here, we don't want to see beverage again, and we don't want to see dessert again. These are things that you can play around, make sure that the menu looks perfect. The goal of this exercise is not to make sure that everything works perfectly for a user, and these are things that need to be meticulously crafted and played around with, but this is just to give you an idea of how we're creating all of this, all of these classes, and how we're manipulating dictionaries, and how we're changing prices and updating prices, and so on and so forth. Ladies and gentlemen, if you don't know, I've been sick. That's why last week I did not provide you with a video. If you're watching this in the future, you have no idea of my schedule. And my voice is starting to hurt. Well, not my voice, my throat is hurting. and my voice, I feel, is gonna start cracking. So let's move on to the challenge. And your challenge is going to be the following. So we're going to start working with data files. First of all, in the same menu item class, add a new method to dict that returns a dictionary with keys being strings representing the item's attributes and the values being the attributes themselves. Next, you'll need to define a function, toDictFunc, that takes in an object and calls the toDict method on that object and simply returns the result. So you can start seeing what we're doing in here. If you've gone through the video where we work with files, reading and writing, you'll know what we're doing in here. We're trying to serialize these objects because we cannot write these objects or read these objects from a dictionary, a .json file if they're not a dictionary. So what we're going to do is each item, we're going to convert its attributes into dictionaries and then write them to a file. And once we read from a file, they are going to be in the form of a dictionary, and we'll see how that will look like. In the menu manager, define a method save to file that takes in a file name and inside open the file in the writing mode opens the file in the writing mode and dumps the menu items into a JSON file. Set the default equal parameter in the .dump to dictfunc. And all of this, if it seems weird, back to the video that I'm going to mention at the top for reading and writing. In the same class, define the last method load from file that takes in a file name, opens the file in the reading mode and loads the data into the menu underscore item dictionary. Be careful of how that data must be broken down. Very, very careful of how it should be, otherwise you're going to get errors. And use the .json file I've provided you with to load the data. So I'm going to give you a JSON file that will contain a lot of items from different categories and different prices and names and etc. So you need to watch out for that. And finally, test out the different methods at every point. So pause the video right now and go do the challenge. Okay, so as you can see, we've created a new method inside of the menu items that is the toDict, and it's defined within the menu items class because the menu items objects are going to be using this, and it has a single parameter that is the self, which again refers to the instance of the menu items class. Now, what follows inside of the method is pretty straightforward. We simply return something, and what we return that something is a dictionary. This basically constructs a dictionary that contains 3 key value pairs. Each key represents an attributes of the menu items object, that is the name, category and price, and the corresponding values are going to be the attributes of the object in itself. So by calling this method, the toDict method, on an instance of the menu item, it returns a dictionary containing the current state of the menu items in a clear format, that is the dictionary format. And this is going to be very helpful whenever we try to write these items to a file, because when you're writing to a JSON, it doesn't understand that this is a menu item or it has a name and category and price and dissects it. No, you have to show it, you have to serialize it into a format that JSON understands, and that format is the dictionary. So let's continue on and create a function, not a method. Okay, and this is our function. Now, what's the difference between a function and a method? It's because the function that is inside of a class is called method. And if you don't know why that is the case, because you need to go watch the functions video and the object-oriented programming video. So here we have a function named the toDictFunc, and it takes in a single parameter that is the object. Notice that it doesn't take the self because this toDict function is not going to be called on an instance, it just gets called on its own. Now, inside, it's very, very simple. We simply return that object on which we call the toDict method. So we take in an object that should be of type menu item right here, and we return the object.toDict. So basically what we're doing is we're adding an extra step that will allow us to access this dictionary right here. And you might be thinking, why are we doing all of this? Isn't it kind of unnecessary? But what this does is, or what it's called is this, it's called a utility or a helper function, and it allows for the toDict method to be called on any past object. And you'll see how helpful this becomes when we work on the next function that is going to be the save to file. Okay, so I believe that before I start writing the code, I said we're going to be creating a function save to file. No, I meant a method that is save to file. But don't worry, like there's no problem in playing around with these words as long as you properly understand what the concept is. But for me as an instructor, I should be cautious with what words I use. Anyway, the method save to file was defined inside of the menu manager. And I'm going to actually, because we have a lot of methods in here that we don't need anymore, so I'm going to make them smaller. And by the way, when I call the JSON right here, you can see that it imported JSON on itself. Maybe you're using a different IDE and this doesn't happen to you, so you might have an error there. So keep that in mind. Anyways, right here we define the save to file, and it takes in the self and the file name. And the execution goes as follows. First of all, we have the with open file name as file. And if you don't know how this works, again, I'm going to refer you to the video about reading and writing. It's a very popular video. A lot of people and a lot of students actually enjoyed this. So basically this line opens a file with a name specified by the file name parameter sent to it in the write mode. So we'll open the file with this file name in the write mode, and the file variable right here represents the file handle used to write data to the file. So we're going to be using this as a variable to tell Python that we're writing to this file, basically. Now, inside of the with block, we have the json.dump and some information inside. So let's go through these. But before I go through every single individual one, this entire line, basically what it does is it serializes the menu items dictionary of the object self into the JSON format and writes it to a specified file, which is this right here. So we have the default right here and the indent. These are kind of weird. This should be self-explanatory. Basically, I'm telling dump or JSON right here if I hover over it. So we're providing it with the object, that is the menu item. We're providing it with the file to which we want to write. Now the default right here is what it does is it takes in every single item from the menu items and it calls the toDict function on it. Because remember when we were printing out right here, remember when we were printing out the menu items, do you remember how they used to look like? I'll just give you a reminder. So right here. So, okay, right here. JSON will understand that we start off with a dictionary beverage as a key, and then it has another dictionary with a key latte. JSON is good with that, but what JSON is not good with is right here, this object. JSON doesn't know how to serialize it. So what we've done in here is we told JSON, whenever you encounter an object that looks like this with menu item and some weird stuff in here, by default, you should use the toDict function on it. All right, so JSON now, it sees beverage, excellent, sees latte, excellent. Now it starts constructing things and then it finds this menu item object. So what it does is it uses this toDict func, sends in, where is it? Sends in the object, that's right here, sends in the object, and then the toDict method is called upon that object, which converts it into a dictionary that JSON does understand, and we can serialize and properly write every single item to it. And finally, the indent argument formats the JSON output to be more readable, with each level of the structure being indented properly. And after we write to that file successfully, we simply print out a menu saved to the file. So if I right click and I run, nothing happens because I didn't call the method itself. So I'm going to scroll down and I'm going to add a few items and I'm going to call it. Okay, so before I run, I need to provide this save to file with a file path. So what I will do, oh, and by the way, I just added 2 items, and notice that I didn't save them in variables. I just created them on the spot and added them to the menu manager. So right here, I'm going to right click and create a new directory, and I'm going to call this exercise 10 files. Just call it files, should be enough. Capital F, boom. So now we have this directory. So now what I'll do is I'm going to say right here that I want to save this in. Wait, let me reformat. Oops. Let me refactor and rename, because I just want to copy it. I don't want to make any mistakes. Boom, exercise 10, and then backslash or /, and we're just going to call it the, what should we call it? Just menu.json. Okay, so now I right click and I run and boom, success. So let's see. Yes, menu save to file. So if I look back right here, I can see that I have a new item that is the menu, and double click and voila. I don't know why I said voila, but look at how beautiful this JSON file looks. We have our beverages, the latte, the coffee, we have our dessert, tiramisu, and we have our main course with pasta carbonara, and apparently it's not written like that. I don't know how carbonara is written, doesn't matter. And I have cheeseburger right here, and I'm starting to cough, I'm starting to die. Guys, I hope all of this is understood. These are, as you can see, separated properly. This is what I meant by serialization, where we had to return name, category, and price as dictionaries. But anyways, let's move on. I need to finish this. I'm about to die. Okay, ladies and gentlemen, we are at our last method. So this method is going to be the load from file, and it's defined within the menu manager class, and it has only 2 parameters, just like the save, the self, and the file name. So when executed, the method operates as follows. First, we have this statement right here that opens up the file or a specific file in the reading mode, because this time we're not writing to a file, we are reading from a file. And the file is accessed using the file variable right here that we've created. And inside the with block, we start off by reading the JSON formatted data from the file and converting it into a Python dictionary called data. So all of the information that's inside of the JSON file is read using the .load, and it's put into the data variable, and this one is a dictionary. Now, the next step is to create menu items from all of these. So first of all, we're going to go through each individual item inside of that data, separating into categories and items, because remember how we have them, and items are dictionaries in of itself, or items, each item is a dictionary in of itself. So first of all, we check if the category not in the menu items, and we do this just because we're checking if that category already exists in the menu items that we already have. So remember, we've created all of these different things in here, and now we're adding them again. So first we check if the category exists. If it doesn't, a new category is created. Now, if once the category is created, it doesn't have to be created. Next thing we do is we go through the items again, because remember, we have a dictionary of dictionaries. So items right here is a dictionary as well. So we can go through the item, and we have the item name and the item data. Remember, we're separating these into keys and values. So once we have that information, we're going to add a new item under the category right here. So self.menu items in that category with the item data. Remember right here, this is wrong. This should not be item data. This should be item name. Yep, there we go. I felt something weird. So remember, the item's name is going to be the key under the dictionaries. So right here, menu item, item name, category, and item. So we're creating a menu item on the spot using the name, category, and the price is accessed from the item's data. So this is our file. Let's go ahead and input that. So I will scroll down and right here, I'm going to print this out. And I've provided you with the JSON file. So what I want you to do is I want you to open it up and drag it right here. Refactor. Yes. So there we go. Oh, I just removed it from my own resources. Copy and paste it. Don't drag it in. Not to self. So right here, what I'll do is I'm going to say menu manager dot load from file. And it's going to be exercise. Will it give me a, no, it will not. So I'm going to simply copy this, copy, paste, and it does not like that. So I will remove these two. And in here, it's menu underscore items. Boom, there we go. So once we've done that, nothing is gonna happen, because, well, we haven't listed anything. So I'm going to duplicate this and move it to the top. And now, again, in here, something that's important. Once you've loaded the data, you don't know what you have inside of it. So we're trying to list items by their category. Doesn't look nice. I recommend that you create another function in here or another method in here that lists all the items under their categories. But this project was ballooning out of control and I didn't know where to add this extra method. So just as a outside challenge, create a method that will allow you to print out everything, including the categories. But I already know what the categories are, so I will double click right here. I'm going to print out the main course and the drinks and the dessert. So main, okay, can I please have main course, right? Is that how it's written? It has to be correct. Okay, main course. I think that will be enough. We just want to make sure that we've imported these correctly. Right click and run, and no errors. Very nice. And let's see what we got in here. Category main course, boom, there we go. Pasta carbonara, cheeseburger, and vegan lasagna. Okay, fellow Python programmers, thank you so much for watching. I really hope you enjoyed. I really hope that you got value from these exercises. If you've gone through all of my beginner lessons and you've gone through all of my exercises, I mean, you are in amazing shape. You have amazing tools in your arsenal and you can start tackling more advanced topics, which I am going to be covering on this channel. So if you want something like that, please subscribe. If you've enjoyed the content, leave me a like. It helps me out a lot, and you just need to continue watching any video that I've provided you. I'm just going to move the mic and you can start watching right here. Let's go. Continue your Python programming journey.